session chair. We are thankful to him for joining us and taking time out of his busy schedule. Dr. Amardeep Singh has an experience of over 25 years in R&D sector. He has extensive knowledge of conflict resolution and water allocations in transboundary conditions, water courses, geographical information science-based modeling, and geotechnical investigations pertaining to large hydropower projects. He has published many national and international peer-reviewed journals and conferences. He is currently a member of soil mechanics team at Central Soil and Materials Research Station, a research station attached to the Department of Water Resources, River Development and Ganga Rejuvenation, Ministry of Jal Shakti, Government of India. He has incorporated changes in the soil and water assessment tool model developed by United States Department of Agriculture in collaboration with the Texas Agricultural Research Station through his research findings. He has contributed immensely in a large-scale international sponsored project involving linkages between forestry, low flows, and sustainable livelihoods. Previously, he has worked with the TERI, that is Energy and Resource Institute, as the placement coordinator, as well as the faculty in charge of environmental modeling and GIS. Thank you, sir, for joining us. And now we will start a technical session. We have 7 presentations in this session. I will just read out the paper IDs. Paper IDs 30, 46, 49, 50, 52, 57, 78, and 173. I would request paper ID 30 to please start their presentation. Paper ID 30 is
yes,
present. Yes.
Am I audible, sir?
Yes, you are audible. You can start your presentation.
Okay, thank you very much. Can you see the screen now, sir?
Yes, we can see your screen.
Okay, thank you very much. Thank you very much from Dr. Singhal and Dr. Jain that organizing this conference. Good afternoon, everyone. My name is Ali Reza Nouri. I am a PhD candidate at Department of Environmental Engineering and Delhi Technological University. Also, I am a faculty member and in Department of Water Supply and Environmental Engineering in Kabul Polytechnic University. The paper that I want to present is about the assessment of drinking water quality in Kabul, Afghanistan. This paper is prepared by me and Professor S.K. Singh, who was head of Department of Environmental Engineering at DTU, and currently he is Vice Chancellor of Rajasthan University. The content of the presentation that included in this paper is introduction, first part, and the second part is the literature review, problem formulation. After that, we have some discussion on methodology and some talks about the result and discussion. Then we will come to a conclusion and references. As we know, water is the substance of life. It's a clear fact for everyone, and most part of the world has faced the shortage of this substance of life and some issue regarding the quality of this vital substance. So various factors can involved in the risk of in this risk, including population growth, urbanization, development, and industrial and agricultural activities, global climate change, and etc. In many parts of the world, groundwater is the main source of drinking water, especially for arid and semi-arid areas. Based on the existing literature, for the Kabul city, groundwater is the main source and the only source that is available for water supply. And the city provides water supply for domestic use through different agencies and different sources. public agencies are the main agencies that are providing water supply. Beside them, private agencies and private wells also exist in the Kabul city. So the quality of groundwater in Kabul city has deteriorated due to various factors. These factors can include lack of sewage system, because the city has not a sewage system yet, high fertilizers usage, and direct disposal of household waste in the surface water. Over extraction can be another reason of polluting groundwater resource, and natural factors may also be one cause of the groundwater pollution. The study area is located in Kabul city. It is the capital of Afghanistan. The total area of the basin is about 496 square kilometers. Precipitation in the Kabul is highly seasonal, and average precipitation in a year is about 300 millimeters per year. The temperature in the study area is about 32, average temperature is about 32 degrees of Celsius in July, and -7 degrees of Celsius in January. So based on land use and land cover, the area is mostly covered by built-up, and the basin elevation is ranging from 1,763 meters to 2,823 meters. This is the map of the study area, which is located in Kabul city of Afghanistan. Basically, it's located in center of Afghanistan. The study area is divided in different zones based on water supply sectors. That is a governmental agency. In this area, which is shown or written as Lugar River, is one part of the major water supply project located here. Money wells that are supplying water is coming from here, and the water is extracting from this site and supplied throughout the whole city. The second major part is Alauddin project. It's called the Alauddin project, which is located in the beside this river, which is called Kabul River. Money wells are located here, and some samples are collected from these wells also. Beside that, we have another small projects, which 1 or 2 samples from each project is collected here, and you can see the characteristic of every project and zone, which is classified by the agency right up here. The drinking water quality that was obtained, drinking water quality data was obtained from this agency. The agency is called Afghanistan Urban Water Supply and Sewerage Corporation, and the abbreviation form is written here. We can see the sampling data is started from 11th of May up to 22nd of July 2020. Totally, we have collected, we have acquired 27 water samples. These parameters, which are included physical and chemical qualities of water samples, are collected and tested. Also, we have some bacteriological, which is include total coliform and fecal coliform of sampled water. This approach and methodology have been utilized to study the quality of drinking water in this study area. We usually use descriptive statistics, groundwater classification based on EC, electrical conductivity, total dissolved solids, and total hardness. Also, some major ion chemistry was applied, correlation matrices, and we also have done some comparison of the quality of drinking water with the WHO guidelines, and found out the percentage of samples that are exceeded the guideline threshold. This table illustrate the result of statistical evaluation. We have water quality parameters and the unit of measurements, minimum, average, and maximum concentration values of every parameters, and also median and standard deviations. Here we have also the WHO guideline and a number of samples that are exceeding from the WHO guideline. Also, we have calculated the percentage. For instance, we see the amount of EC in drinking water in Kabul city, which shows that 4 samples out of 27 is exceeding the WHO guideline, which is 1,500, and it is about 15% of the total samples that were collected. In this slide, we can see the classification of groundwater according to electrical conductivity. Based on EC, we have 4 types of water. One is good, the other one is permissible, doubtful, and unsuitable. Fortunately, we don't have any, based on this classification, we don't have any unsuitable samples. But we have doubtful, which is about 4%, and most of the water samples are falling permissible. And we have some good water sample as well, which is located in mostly north part of the study area. Here we can see the classification of groundwater based on TDS. Based on TDS, we have desirable samples for drinking, permissible for drinking, useful for irrigation, and unfit for drinking. Fortunately, we don't have any samples that are fallen unfit for drinking, but most of the samples, which is about 78%, are permissible for drinking. But the desirable for drinking water, which has less than 500 mg per liter hardness, is very less. It's about 7%. Here also we have groundwater classification based on TDS content. Again, we measure the TDS. Based on this classification, we have 4 types of water. The main and major type of samples that are tested are located in freshwater type. Beside that, we have brackish water type, saline water type, and brine water types are 0 samples. Here also we have groundwater classification based on TDS content, which shows the hardness of water. We have, sorry, it's not TDS, it's hardness. Based on hardness, we have soft water samples, moderately high, hard, and very hard. Mainly the samples that are tested for this study area are fallen in very hard, and it shows that the groundwater in Kabul city is very hard, about 90%. We can say that very hard and hard water. We don't have any moderately high or soft water in this study area. This scatter plot shows the percentage of different parameters which are measured for this study area. For example, EC and TDS have the high percentage in this study area. Likewise, calcium and magnesium, chloride, sulfate has the lowest concentration in all samples. This is a matrix of correlation coefficient of different water quality indicator. It shows the correlation between two different water quality indicator. For instance, TDS has a very high correlation with total hardness, with calcium hardness, with calcium, magnesium, chloride, sulfate, etc. The blue color illustrates the highly positive correlation, and the red color shows the negative correlations. So we can say in conclusion that groundwater is the main source of water supply for the city of Kabul, which has a population of about 5 million. The current study analyzed the quality of groundwater in Kabul city, descriptive statistics, groundwater classification based on EC and TDS, total hardness, measure ion chemistry, and correlation matrix was used. The quality of drinking water has been compared with WHO guideline. The output of the study indicate that maximum concentration in many parameters, including EC, TDS, total hardness, calcium, magnesium, chloride, sulfate, nitrate, iron, aluminum, and also fecal and total coliform exceed the WHO threshold with different percentage. Based on EC classification, we can conclude that groundwater is mainly, it means that about 90% classified as permissible class, which is permitted to use for drinking. The TDS classification indicate that about 88% of water samples are acceptable for drinking, and about 85% of the groundwater is classified as freshwater, while only 15% of the taste samples are brackish water type. The total hardness of water indicate that groundwater in the Kabul city or in the Kabul basin is classified as hard and very hard type. About 90% of samples are very hard, and about only 10% are classified as hard water type. So the strong correlation based on correlation analysis, the strong correlation exists between EC, TDS, calcium hardness with calcium, alkalinity with bicarbonate, total coliform and fecal coliform. Coliform indicates that they might have the same regions. The finding of drinking water quality study demonstrate that the water quality in Kabul basin is poor with several parameters exceeding the WHO guideline. That's all from my side. Thank you very much for your attention.
Thank you, Mr. Noori, for your presentation. The session is now open for question and answers. I would request Dr. Amardeep Singh, sir, if there are any queries and questions.
Thank you, Mr. Noori, for such an interesting presentation.
Thank you, sir. Thank you very much.
I would have liked something. You have looked at the matrix of correlation coefficients.
Yes, sir.
But have you gone any further, because this work was done in 2020? I would have liked if you had gone further, and based upon these correlations, you could have developed some equations.
Yes.
So that one parameter is showing very strong correlation with 4 or 5 parameters. Then we can see if we can use those parameters to predict that parameter.
Yes.
Maybe you can work along in this direction also.
Yeah, actually, we considered this also, and thank you for your good suggestions, sir. We are doing some modeling that on that models we will use artificial neural network based on this correlation matrix that you can see here. Yeah, exactly. Based on this, we can estimate some other parameters. For example, we can develop some models that without doing any test, we are able to measure or to predict the concentration of water samples. Fortunately, it gives very well result also. We have done, but it's not completed yet.
Okay. You have formulated the equations.
Yeah, we have formulated the equations, and the model has been developed. Some parts, just some parts, yeah.
Okay, okay. Any other questions from anyone?
Any other questions from participants? Okay, so we will move to our next presentation. And I would request all the participants that you please limit your presentation to the maximum of 10 minutes, not more than 10 minutes. So our next presentation is paper ID 49.
Okay, thank you very much.
Thank you, Mr. Nori. I
Thank
would
you.
request paper ID 49 to start your presentation. Paper ID 49.
Am I audible, sir?
Yes, you are audible. You can please start.
So I'm not able to share my screen because Noori sir's screen is still being shared.
Mr. Nori, can you please close your screen? Yeah, now you can share.
So is my screen visible?
Yes, it is visible. And please limit your presentation to 10 minutes, okay?
Yes, I'll try. Good afternoon, everyone. My name is Ricky Sarma, and I am a PhD research scholar at the Department of Environmental Engineering in Delhi Technological University. Today, I will be presenting the findings of our study, which is the comparison of the performance of artificial neural network and multiple linear regression in prediction of a groundwater quality parameter. The co-author of this paper is Professor S.K. Singh, who is a professor in the Department of Environmental Engineering, DTU, as well as the Vice Chancellor of Rajasthan Technical University in Kota. So these are the contents. As we know, the groundwater is an important resource in India. It is a very vital and essential resource of our life support system. According to the CTWB report, this is the Central Groundwater Board's annual report of 2018-19, 89% of the groundwater in India is used for irrigation, and 11% is used for domestic and industrial use. So groundwater is an important resource for us, and so to evaluate its suitability for various uses, we need to find out whether its quality is suitable or not. And there are many mathematical, statistical, computational methods, geospatial technology, water quality indices. A lot of different methods have been implemented, and they have been applied to simulate and assess the groundwater quality parameters. Among the various groundwater quality parameters that are used to assess its quality, electrical conductivity is a major hydrochemical parameter. Electrical conductivity is also a measure of the salinity. And high EC levels or high salinity levels reduces the osmotic activity of crops, and it also reduces the crop's ability to take up or absorb water and other nutrients. So it is an important irrigation parameter. So EC is used as a very important irrigation parameter. And apart from that, because EC is a measure of the ionic strength, it also tells us about the concentrations of different ions present in the water. So EC might be dependent on, say, sodium, calcium, magnesium, potassium, or chloride or sulfate ions. And so the high EC levels also means a high ionic strength of these ions, which in turn also affect the drinking water quality, as well as it may cause some gastrointestinal problems or other health problems also if there are high EC levels in the drinking water. So it is very important to monitor the EC by various methods. So we need to look for cost-effective methods. We need to look for fast, reliable methods, which can predict the EC for a given water sample. So recently we have seen that ANN, artificial neural networks, have been broadly applied in many water quality problems, and they have been very useful because of two reasons. One, because of two advantages. ANN models, they do not rely on any physics-based modeling approach. So because of that, because there is no physics-based algorithm required, the ANN models are quite fast, and they can also be quite flexible. And secondly, ANN models are also able to simulate non-linear equations and non-linear relationships between independent variables. And so that's why ANN models see certain advantages. In literature, there are many papers that have seen the usage of ANN models where a lot of these ionic concentrations have been used as inputs to estimate the water quality parameter, is either TDS or maybe water quality indexes also being simulated. And in one paper, which is the last one, The ANN has also been compared with MLR. MLR is the multiple linear regression to predict groundwater quality parameters. So multiple linear regression is a sort of an advanced form of a simple regression model where the prediction of the output or the prediction of the dependent variable is done by predicting the linear relationships between the independent variables. So this paper has predicted both, and they have compared the efficiency of both in predicting groundwater quality parameters, and they have seen that MLR has performed better than ANN in predicting EC, total hardness, and TDS, but ANN has performed better than MLR in predicting the pH. So given this background and given this literature review, we have formed these research questions. Can we predict the EC of groundwater of Delhi using ANN? And if yes, how does that compare with the efficiency of MLR in predicting the EC? So for this particular study, we have performed two modeling approaches. We have taken two modeling approaches. One is ANN and the other one is multiple linear regression to predict the EC value of groundwater of Delhi. So ANN is a network, and it replicates biological neuron processing, and it consists of one input layer, one hidden layer, and one output layer. As we can see in this figure, so we have these inputs, which are denoted by X. They are multiplied by their corresponding weights, Wji, in the input layer, and they are then fed in the hidden layer. So the hidden layer then gives out the outputs, which are then multiplied by their corresponding weights, Wkj, and they are fed in the output layer, and then the outputs are given, which are Y1 to Yk. So this is a simple feed-forward ANN network, which is just a representation of that. And for our study, I have this is the second figure, which is the ANN architecture of our EC prediction. So we have all these inputs, the INA concentrations, and these are taken as inputs in the input layer. They're multiplied by their corresponding weights. We have the hidden layer. There may be one or more than one hidden layer. This is a simple representation. And then moving on, we have the output layer, which is going to give us the EC. The second model that we are using is the multiple linear regression, which is denoted by this mathematical formula. So Y here is the dependent variable, X is the independent variable, B is the regression constant. And so the multiple linear regression, it basically is going to predict the dependent variable by finding out the linear relationships between the independent variables. The study area that I've chosen is Delhi. So groundwater data records are taken from the Central Groundwater Board. There are 64 locations, monitoring stations that the CGWB monitors the samples of. And I've got the data of May 2019 for 64 sampling locations. And these had the coordinates, the data set had coordinates of the sampling locations, as well as the pH, EC values, and the INA concentrations given in milligram per liter. And there were no missing values on the data set. The data set was complete. So finally, the overall methodology can be depicted in this flow chart. So the data collection was done from the Central Groundwater Board. After that, to enter the inputs, we have to first find out which ionic concentrations are contributing towards the EC. So just like the discussion we had on the previous presentation, the Pearson correlation matrix was applied in SPSS software to see which ions the EC was dependent on. So once that was found out, the input data set was normalized. So this normalization of the data set was done using this formula on the left. The normalization was done between values of 0 to 1. So the data set was converted to values between 0 to 1 so that the larger data did not override or did not dominate over the smaller values. Then the data set was divided into training and testing subsets in the ratio of 80:20, meaning that 80% of the data set was used for training. That is around 51 samples were used for training, and 20% of the data set, approximately 13 samples, were used for the testing. Then we train the ANN networks. So the training of the ANN networks requires choosing the optimal number of hidden layers and neurons. So there is no set rule or no set formula or anything by which we can choose the optimal number of hidden layers and neurons. It was done by trial and error method. And so what we did was once we trained the network, we compared the estimated and the observed values, and we also checked the MSE being the mean squared error. So only those networks were taken for which the mean squared error was the lowest. So in case it wasn't low, then we go back and then we again select a different combination of hidden layers and neurons. So that way we have trained a number of networks. We have checked different networks. for which the MSE were the lowest. And then those particular trained networks were only then used to predict the EC. And then the EC values which were given by these ANN networks were also compared by the EC values given by an MLR model, a simple multiple linear regression model, for the testing stage. And those were compared using accuracy measures R-square and RMSE. R-square is the coefficient of determination or correlation coefficient, and RMSE is the root mean squared error, which is found by these formula. So moving on with the results, first the Pearson correlation matrix is telling us that the EC, we can see the EC is dependent on chloride, sulfate, calcium, magnesium, and sodium. So I've highlighted them in bold. We can say they're also statistically significant. So also, but we can also see that the EC is also dependent on bicarbonate, nitrate, fluoride, and potassium, but the correlation coefficient is less than 0.5. And also in some cases, like in bicarbonate and potassium, it is not statistically significant also. So we can say that those parameters are not contributing as much towards the EC as these 5 are, which are highlighted in bold. So when we are going to be training the network, we are only going to be using these 5 values. So we'll be using chloride, sulfate, calcium, magnesium, and sodium to predict the EC in our ANN network. So we have 5 inputs. So when we are training the inputs, training the model using our 5 inputs, we have these architectures, these networks that are found. So 511 means there are 5 inputs, 1 hidden layer, and 1 neuron. Like I mentioned during the methodology stage, there is no set rule. So we have tested different combinations of hidden layers and different neurons in each layer. For most computational problems, for most water quality problems also, a single hidden layer is usually sufficient. So when we talk about 1 hidden layer, I have changed the number of neurons in that 1 hidden layer. And I have found that for neurons more than 4, the error, the mean squared error, MSE, was not significantly changing much. So for this particular scenario, for 1 hidden layer, 4 neurons gave us the lowest MSE, so we've considered that. Then we've also taken 2 hidden layers, and we've also changed the number of neurons in each layer, and have found that more than 3 neurons in 1 layer also did not change the MSE, the error, significantly. So we've taken these 3 scenarios, we've taken 3 ANN networks which have the lowest MSEs. Also hidden layers more than 3, like there is no need to go more than 2 hidden layers because the MSE.
Ms. Ricky Sharma, please conclude your presentation.
Okay, I just have 3 more slides. Please. So there was no significant change in the MSE more than 3 also. So we have only checked for 2 hidden layers and 1 hidden layer, and these are the networks that we have finally selected based on the lowest errors. So these are the networks that were given. This ANN and MLR models, they were both run in RStudio. So these were the plots of the ANN networks. Once we have selected the 3 ANN networks with the lowest MSEs, we've used those trained ANNs to predict the EC for the testing stage. And so we have the R-square RMSE values for both training and testing. So we can see that the ANN has actually performed quite well. We've got very high R-square of 0.97, 0.957. But when we are comparing it with the MLR has much higher R-square of 0.993. And also our RMSE is the lowest for MLR. So we need low RMSE values. So RMSE is lowest for MLR. So we can say that to predict the EC of groundwater of Delhi, the MLR has actually outperformed the ANN. When we are looking for the testing stage and we are fitting the observed and predicted values of EC for the testing stage, we see that this ANN network was able to fairly fit well, but our MLR, because we have higher R-square and lower RMSE values, was able to fit much better, and it fits the best. So to conclude from a research question, can ANNs be used for prediction of EC? Yes, ANNs can be used for the prediction of EC, but comparing ANNs with MLR showed that the MLR actually outperformed ANN because in terms of the accuracy measures for both the training and the testing stages. So to conclude, EC prediction is a generally simple problem and it can be modeled easily using regression. But there can be further research done to improve the performance of the ANNs as well. In this study, I have only used 64 data points, but if I had 64 data points for more number of years, say maybe 10 years, I would have 640 data points. And if I had a larger data set, training of the ANN model would be much better. So maybe more research can be done, and that could be a further scope of this study. Also, I have not included a validation argument, so that could also be another scope of the study, that a validation argument can also be included with a larger data set. And finally, this is a fairly simple problem to demonstrate the application of ANNs, which is easy. So more models can be developed for prediction of more water quality parameters, water quality index, irrigation parameters, as well as irrigation water quality index. These are some of the references that I've used. Thank you.
Thank you, Ms. Ricky Sharma, for the wonderful presentation. The session is now open for question and answers. Dr. Amardeep Singh, sir.
Okay, thank you.
If there are any questions, you can please proceed.
First of all, I must congratulate the speaker on this is a very fine piece of work. And the thing which impressed me most was that the literature review is very recent. The last paper that you have cited is 2022 paper. So this is
Yes,
very.
sir.
And one more thing I observed was in that paper also MLR was found to be performing better than ANN, and your
Yes,
results
sir.
indicate the same. So this
Yes,
is
sir. Same results were obtained, yes, sir, for both the papers.
okay. Now I have one or two questions. Like once you have normalized everything, have you
Yes.
excluded any outliers? Like you must be having some values which are fairly high and which are not reasonable. Have you excluded any of those?
No, sir. When we had normalized, actually, all the values were coming between 0 and 1. So we did not have to exclude anything.
No. Okay. The values are coming between 0 and 1.
Yes, sir. Yes, sir.
In the formula, we are having the maximum value. So that is being used to calculate each value. So if the maximum value is an outlier, then it gives a lot of error in all the calculations. So generally in these studies, such kind of studies, we normally look for outliers and we remove those outliers. You can take this suggestion and you can incorporate in further
Yes.
works.
Sure, sir. Yes, sir.
Secondly, in your model, you had shown, I think, 6 parameters which were affecting, but you have taken only 5.
No, sir. 5. There are 5 in.
You had shown bicarbonates also, I think, in the second, third slide. Okay, that is not my question. My question is, like, you have seen that MLR is performing better than ANN.
Yes.
Have you tried to remove one of these parameters and then done the comparison again? Then remove 2 parameters and done the comparison again. Maybe for 1 or 2 of the cases, you might get better results from ANN.
Yes, sir. So we can try doing that. I can try checking if what happens when we change the number of parameters also.
Please do
in
that.
The next step of the
result.
yes.
Yeah.
Yes, sir. So thank you so much, sir, for the suggestion.
Thank you. Thank you.
Thank you, sir, and thank you, Ms. Ricky Sharma.
Thank you, sir. Thank you so much.
Our next presentation is paper ID 52. Ms. Ricky Sharma, you may close your screen. And paper ID 52, you may start your presentation.
Good afternoon, everyone. Myself, Rachna Garg.
And please limit your presentation to a maximum of 10 minutes, not more than that, because we are running out of time.
Yes, sir. I will do it. Okay, so my paper ID is the 50 and title of my paper is the source and toxicity assessment of cyanide from the iron and steel industry wastewater. And authors are the co-author of this paper is the Professor S.K. Singh, head of the Department of Environmental Engineering, DTU, and also currently VC of Rajasthan Technical University, Kota. So this is the presentation plan for my presentation. As we know that the development and industrialization are synonymous with each other, and with the development there is an increase in the industrialization, and industrialization growth has resulted in the addition of the certain molecules and chemicals which have direct or indirect effect on the ecosystem and human health. And cyanide is just one such kind of the molecule which have a very harmful effect. And cyanide in the environment, cyanide will be present in the various forms such as the hydrogen cyanide, salts, and variety of cyanide complexes such as ferrocyanide and zinc cyanide. Cyanide, it is a radical of the carbon and nitrogen. Cyanide do not effectively retain on or adsorb on the soil. Therefore, mainly remain in the aqueous form and often result in the complex formation with metallic pollutant in the industrial effluent such as the iron, copper, and nickel and zinc.
Excuse me, sorry to interrupt, Ms. Rachnagar. Can you please run your presentation in slideshow mode?
Okay. Is it okay, sir?
Yes, now is it okay? It is okay.
So the complex of the metal and cyanide, which is also known as the metallocyanic complex, has a broad biological and chemical stability. And on the basis of the stability, cyanide complexes are divided into the three categories. That is free cyanide, weak acid dissociable VAD, and strong acid dissociable SAD. So the first free cyanide, it is the total cyanide content of cyanide ion and the hydrogen cyanide. Free cyanide exists or present as the hydrogen cyanide at acidic pH means less than 7 and hydrogen cyanide ion is present at pH greater than 10.5. Free cyanide is most toxic form of the cyanide and it is 1,000 times more toxic to the aquatic life than human. Next category is the weak acid dissociable. It is the complex of the cyanide with metals such as the cadmium, copper, nickel and zinc, and they are considered as a weak moderately strong complex which under mild acidic condition release cyanide ion. Last category is the SAD, that is strong acid dissociable cyanide. These are the cyanide complex with the silver, cobalt, gold and iron, and they need the very strong acidic condition to break and release the hydrogen cyanide. And on the basis of the toxicity order, free cyanides are the most toxic, then the WAD, and after that SAD. So for the present analysis study, various research papers were studied. Some important papers are presented here, and these were the very important in developing understanding the how cyanide is present in the environment, how it is released anthropogenically, and up to what concentration level cyanide can be released into the environment so that this concentration may be tolerable to different species. So for the present study, cyanide is particularly considered because it is the toxic even at a very low concentration, form the very stable substituent in water, and it is broadly manufactured in different kinds of industry and form the toxic substituents such as hydrogen cyanide, potassium cyanide, and sodium cyanide. And it causes the various neurological and the health effect even at low concentration. Beside this anthropogenic source of the cyanide, it is also naturally present in the environment. It is released during the volcanic activity, during the biomass burning, and photosynthetic activity of the plant, algae, fungi, and bacteria also release cyanide. It is also present in the some food items such as the cashew nut, almonds, apple seeds, beans, potato, like tubers, and in animal kingdom such as beetles, centipedes, and some butterfly. In the food item, cyanide is present as the cyanogenic glycoside, and most common cyanogenic glycoside is amygdaline. Therefore, it becomes important that we should we should know that up to which level environmental species could tolerate the cyanide condition concentration release anthropogenically, so that the strict standard and regulation can be made to protect the environment. And iron and steel industry is one of the biggest and the fastest growing industry, release a huge quantity of the cyanide concentration, cyanide containing wastewater into the environment. So for the present study, analysis is done in terms of numerical value of L50 and EC50. LC50 is the lethal concentration and EC is the effective concentration. So numerical value of the LC50 and LC50 are generally determined after the 44 hours of the.
Can you please repeat what is the difference between LC and EC?
LC is the lethal concentration and EC is the effective concentration.
Okay.
So are the generally determined after 44-hour exposure of the body to the predetermined doses or concentration of compound containing the cyanogenic and the mean effective concentration is the concentration of substance in an environmental medium expected to produce a certain effect in 50% test organism. Usually we use the planktonic crustacean, that is Daphnia, in a given population under a defined set of conditions. So in the concentration of the free cyanide in the integrated steel plant blast furnace and the coke oven plant wastewater is 4.78 and 5 mg per liter respectively. So from the table we can see that the free cyanide concentration in this particular industrial wastewater is toxic to the most of the species of feces. And similarly, we can see that it is similarly toxic to the invertebrate species and also to the algae. Although we can see here that it is non-toxic to the higher, this concentration is not toxic to the higher species such as mice, but the long-term exposure can produce a lethal effect in the higher organism also. So based on this, we can conclude that in the last few decades, interest has grown in the cyanide concentration determination because of its industrial and commercial significance, as well as its prevalence in the food items. This current studies show that the iron and steel industry's ongoing production of the vast amount of the cyanide-bearing wastewater can contaminate the soil, water, and may be harmful to the species present in the aquatic environment, such as the fish, algae, invertebrates, and other higher organisms. So there is a need to implement innovative strategy and the strict standard to mitigate the adverse environmental impact of the cyanide pollution discharge in the iron and steel industry. So these are some references which I had used thinking.
Thank you, Ms. Rachna Garg, for your wonderful presentation. The session is now open for question and answer session.
Thank you, Ms. Dutt, for such an interesting presentation. I would like to know one thing. Why have you taken iron and steel industry? Because in the literature review, you have not shown any paper which was showing that this is the major polluter and or major source of cyanide. How did you on this?
Okay, sir. I have taken iron and steel industry because the current production of the India is increasing, and we are at the second position worldwide in the production of iron and steel.
Okay, but can you tell me what is the total percentage of like if total cyanide in the atmosphere is 100 units, how much of that is given by iron and steel? Some rough estimates are there in Indian scenario or worldwide, some values are there.
Sir, actually, from the iron and steel industry, major pollutant is the cyanide, but I don't have any concrete data to show you how much percentage.
Okay, no problem, but you can do some literature review and look at these values.
Okay,
because industry, we would like to see how much of the total concentration is given by this industry.
Yes, sir. Okay.
Add more value to your work.
Yes, sir.
Thank you.
Thank you, sir.
Any other question from participants? Okay, so now we will move to our next presentation, that is paper ID 52. Paper ID 52, you may share your presentation.
Sir,
Yes, it is visible. And please limit yourself to maximum of 10 minutes.
sure. Good afternoon, everyone. I'm Malika Vashisht, PhD scholar in Department of Environmental Engineering, Delhi Technological University. And the topic of my presentation is potential of individual leaf traits and leaf-associated microorganism in the removal of particulate matter and in the removal of particulate matter. And the author for this paper is me and my guide, Professor S.K. Singh. Okay, so as it's very well known that air pollution is a global issue which has highly accelerated due to unorganized and rapid urbanization. With this increase in number of increase in number of urban areas, the urban population has overgrown from 55% to 68% by 2050, which will result into greater number of people exposed to hazardous air. According to a survey conducted by WHO, 90% of the urban population lives in areas that do not comply with air quality guidelines of WHO for particulate matter. Particulate matter is the most adversely affecting air pollutant and present largely in the environment, causing high risk of cardiac disorders and respiratory ailments. Apart from human beings, high level of PM levels also affect the environment, animals, vegetation, and other component of ecosystem. Furthermore, with the recent estimate of 8.8 million annual deaths associated with ambient air pollution, there is a clear and urgent need to identify the solution to reduce the air pollution. Considering the deteriorating effect of urban air pollution, the green spaces are considered to be very effective in the abatement of air pollution, primarily due to their capability to dry deposit of pollutants on their leaf surface. Urban forest and individual trees are the major component of urban green vegetation, delivering provisioning cultural and regulating services. Out of all the component of trees, leaves are the most vital and thoroughly researched part of the air pollution reduction, as they accumulate pollutant on their surface, making the air filtering capacity of urban trees an alternative approach to promote urban management of air pollution. However, the ability of trees to mitigate air pollution differs significantly from species to species based on their height, canopy size, leaf size, and leaf characteristics. Recently, it has been observed that the presence of microbes like bacteria, yeasts, and fungi on above ground parts of plants can significantly improve the efficiency of trees in removing air pollutant from atmosphere, which is known as phyloremediation. The objective of this study is to highlight the characteristics of leaves which contribute in combating air pollution, and also to understand the role of microorganisms associated with leaves in improving the air pollution reduction. And finally, recommendations have been given which could possibly improve and promote research in this area. There have been several studies which focus on phyloremediation of PM particulate matter primarily by leaves of plant, because leaves are in the air for most of the time and has a tendency to deposit pollutant on their surface, which make them efficient in reducing particulate matter concentration from ambient air. The leaf shows great diversity in their characteristics from species to species, which impact the PM accumulating efficiency of the tree species. Hence, phyloremediation is one of the most significant topic of research to combat air pollution. The characteristics of leaves which are positively correlated to reduction of air pollutant are presence of epicorticular wax, dense stomatal grooves, presence of trichomes, and rough surface area. And this figure shows the variation in leaf characteristics and their performance in improving the air quality. As we can see, the red ones shows the characteristics which show weak performance in combating air pollution, whereas the blue one shows the characteristics of leaves which highly contribute in mitigating air pollution. So this is a general list of leaf traits which are beneficial in removal of air pollutants. Trichomes are considered to be good in removing particulate matter, to capture particulate matter in them. Wax, in the same way, wax covers, roughness of the leaves, leaf size, leaf shape, shape like ovate are mostly considered to be good. Small leaves are considered to be good in effective accumulation of particulate matter, and many more. So now, what is the role of leaf-associated microorganism in improving the air quality? Accumulation of particulate matter on plants mainly occur through deposition on the leaves, which varies with factors like leaf area index and deposition velocity. However, it has been observed that when microbes like bacteria, fungi, and algae, not algae, are associated with leaves, the efficiency of reducing concentration of particulate matter and other pollutants like VOCs increases. Through the mechanism like leaf absorption, microbial biodegradation, and metabolic assimilation, the microorganism can improve the pollutant capture efficiency of plant. Plant associated with microorganism can improve particulate matter capture efficiency by degrading and sequestering pollutants and promoting their growth, leading to increase in leaf area index. Microbes can also reduce particulate matter toxicity in plant by using their antioxidative capacity. So this is the list of some microorganisms and their role in capturing particulate matter, like actinobacteria reduce the aromatic hydrocarbons. Chemolithoautotrophic bacteria have the tendency to reduce NO2. In a similar way, different microorganisms have been studied which help in reduction of particulate matter concentration. Now, so the conclusion from this, the findings of this study can be concluded that based on the findings discussed above, one can say that a plants present in the urban ecosystem as well as the organism associated with them can serve as an eco-friendly and a cost-effective alternative due to their tendency to absorb and adsorb pollutant via leaf stomata, which influenced by species-specific characteristics like leaf shape, leaf size, and leaf feature, and external factors like location, meteorological parameters such as wind, speed, and direction. Therefore, systematic investigation of anatomical, physiological, biochemical, and molecular mechanisms should be done to select the important tree species. The microbes in phylosphere are not studied much, and many of them are not culturable. Research on proper collection, identification, cultivation method must be carried out so that isolated microbes can be used for life colonization. Thorough tests must be introduced to identify specific plant microbes groups that can effectively reduce significant air pollutant. Finally, research and development related to phyloremediation need to be done in a multidisciplinary manner with a collaboration among researchers on regional, national, and international scale from different academic backgrounds. These are my references. Thank you.
Thank you, Ms. Malika Vashisht, for your interesting and wonderful presentation. The session is now open for question and answers.
Thank you, Ms. Vashisht. This was a very interesting presentation and this work is very good. This work is very timely because the effects of air pollution are really significant and we really need some of these techniques to solve these problems. And even though I am saying this paper is very timely, but I would have liked to look at some numbers. You have talked in terms of qualitatively. You have not said if there are so many leaves, this much is the area, this would be the reduction in PM. So have you arrived at some numbers? Do you have some figures in terms of numbers also?
So actually, the quantitative analysis varies from area to area and species to species. For my current study, the area will be Delhi because I live in Delhi only. So I have not reached to the research part, but I will be applying different models to identify if this tree has this deviation, diameter, breast height at the so how much particulate matter it can accumulate. So on the basis of that analysis will be done. The different leaf specimens will be collected from different locations based on the land use, like from commercial areas, industrial areas. So on the basis of that, I will be comparing these in quantitative terms. This is just a qualitative, it's just an overview of.
Because you have basically done the literature review and you are presenting
Yes, sir.
the literature review.
Yes, sir.
This is a very timely study and I would like to know the results.
Okay, sir. Sure.
Yes, for your PhD.
Yes, sir. Thank you, sir.
Thank you, Ms. Malika Vashisht, and thank you, Dr. Amardeep Singh, sir. May I now request our next presenter, paper ID 57. Paper ID 57, you may now share your screen. Please unmute yourself. You are not audible.
Audible?
Yes, now you are audible.
Good afternoon, everybody. Myself, Shaz Ahmed, research scholar in IIT Patna. And today, the topic of my presentation is assessment of fluoride in groundwater and its correlation with various physicochemical parameters in Gaya Town, Bihar, India. And the work we have completed with Krishna Niti, again the research scholar of IIT Patna, and my guide, Dr. Reena Singh, assistant professor, National Institute of Technology, Patna. So this is the content, how I will proceed, introduction and literature review, and so on. First is introduction. A healthy lifestyle requires clean and safe water. That is the importance of water. Why we need clean water. So poor quality of water leads to many health problems and many social disparities for peoples. Okay. So in certain part of the world, access to clean drinking water is difficult in economic, environmental, and budgetary constraints. These are the reasons why it is difficult to access clean water. So these are the WHO data, which have told that about 783 million people across the world have the lack of the clean water. So it is predicted that more than half of the humanity will suffer from a drinking water scarcity by the year 2025. This is by Lascaux et al. 2021. So drinkable and consumable fresh water is more often derived from the groundwaters, and because it is a higher microbial activity. Even so, several geological processes have led to an increase in the groundwater contamination. It is common for the rural water sources to be contaminated by many factors like discharge, industrial, agricultural, and urban effluents. Okay. The burden of the waterborne disease from consuming the contaminated waters are one of the main reasons why we need the fresh waters. So what is fluoride? Fluoride is an ionic form of the elemental fluorine. It is negatively charged and will not remain as a free elemental form. Fluoride has a higher affinity for calcium, so it is therefore very compatible with the teeth and bones due to its affinity for calcium. These are the natural sources like of minerals, mapping aerosols, volcanic emissions, and evaporations. And these are anthropogenic sources. It includes both industrial and agriculture. Industrial, like bricks, textile industries, glass, semiconductor, and so on. In agriculture, pesticides, insecticides, biomass burning, etc. These are the source of fluoride. In India alone, endemic fluorosis is thought to affect around 1 million people and is a major concern in 22 of the 29 states. Bihar is one of the states where problem of fluorosis is widespread, affecting 8,188 villages in 9 districts have high fluoride concentration in groundwater. So these are the districts of the Bihar, which is contaminated from the fluoride concentration. So Gaya, Navata, Rohtas, Katihar, Munger, Bhagalpur, Shahnawaz, Aurangabad, and Jamui. These are some literature review I have gone through. These are again some literature review. The research gap. The literature, whatever I have gone through the literature review, and many methods are used for the defluoridation process to remove the fluoride from the drinking water. But no method is much more effective. Some method is effective, but it is cost, but it involves cost. Some method is cost effective, but not so effective in the removal. And if it is effective, then the main important concern is after removing the fluoride, its disposal is the main concern. So we are aiming to remove the fluoride with cost-effective process, with high efficiency, with the regeneration of the adsorbent which we have used. And moreover, if we are able to use the locally available waste materials, then it's much more beneficial for us in two ways. The first is we have removed the waste material, we have used the waste material, and in the second way, we have removed the fluoride from the waste material, it is not effective. So these are some problem statements which I explained just earlier. So the material and methods. Sample collection for analysis. Groundwater samples were accumulated from 13 sites in the Yarton being monsoon, and it's kept at 40 census for the further analysis, and all the physical chemical parameters analyzed in the laboratory of NIT. So this is the statistical analysis. We have done the correlation analysis, and with the help of the correlation analysis, we can generate the degree of correlation between the two different variables, how the two variables are correlated with each other, and the extent of correlation we can find through the correlation matrix. So we have done the correlation matrix, Pearson correlation, and if the value is Pearson coefficient is less than 0.5, then it is less significant. We count this as a less significant, and if the value is greater than 0.5, then it will be added as a significant factor. So 0.5 is above is considered as significant correlation, and below the 0.5 is not a significant correlation. So these are the various variables: fluorine, pH, EC, TDS, calcium, magnesium, fluoride, carbonates, sulfate, nitrate, bicarbonates, and these are the units for each measurement: the minimum value, the maximum value, the mean, the standard deviation, and the permissible limit set by the BIS. This is the correlation of fluoride with physiochemical parameters. You can see that the fluoride, the correlation of fluoride, that calcium, magnesium, and carbonate, these three are highly correlated with the fluoride. So the conclusion is, in the Gaya district of the Bihar, fluoride contamination of the groundwater, we have gone through the investigation of the fluoride contamination, and they have found that most of the sites are fluoride contaminated. And after the correlation analysis, we have seen that some are negatively correlated with the fluoride and some are positively correlated. Negative correlation are with carbonate and zinc, and the positive correlation is with that of magnesium. So these are some differences which I have used in my study. Thank you.
Thank you, Mr. Ahmed, for this wonderful presentation. The session is now open for question and answers.
Thank you, Mr. Ahmed. This is a very good study, and as you have shown that the extent of fluoride is really very high in 9 of the districts of Bihar. So this is a timely study and the results are really needed. Have you suggested any remedial measures? You have shown in the last slide some wells or something. The last slide you have some filtration plants.
So mainly for the fluoride removal, the best approach is adsorption process. One of the best approach, because we have that method is also cost effective, and the extent of you can say that the extent up to which we can remove the fluoride is best achieved with the help of the adsorbents. So there's a list of adsorbents, and through which we can remove the fluorides. And currently I am working on the waste material like you have heard the marble waste, which we have used in the house, marble waste, and also so we are working on that, and we are finding a very good result.
Are they being used somewhere like in any of the districts? Are the results being applied? Like, are we using something, some of these adsorbents to remove fluoride, or it is so far only theoretical results?
I'm not getting this. Please repeat.
Like we are saying that some adsorbents should be used to remove fluoride. Are we using these adsorbents at some of the places where very high concentrations like hotspots are there?
There are many number of papers which they have used at the hotspot site, and which gives a good result. And on the basis of that results, we are proceeding for the next adsorbents, and we are finding the adsorbents which can remove much more better than that, which earlier many researchers have used in adsorbents, which give a good results.
So you are still carrying out these studies?
Yes, sir.
Okay. Thank you.
Thank you, sir. Thanks a lot.
Any questions from participants? Okay, so thank you, Mr. Ahmed.
Thank you, sir.
Our next presentation is paper ID 78.
Good afternoon, sir. Is I am audible, sir?
Yes, you are audible.
Okay, sir. Thank you, sir.
Please limit yourself to maximum of 10 minutes.
Good afternoon, sir. Good afternoon, everybody. Namaskar to all of you. I am Abhijit Das. I am Abhijit Das. I am affiliation is Sivaraman Global University. Excuse me, sir. Some noise is coming.
Mr. Shaz Ahmed, could you
Mr.
please
Shah
mute
Ahmed.
yourself?
Mr. Ahmed, can you please mute?
Okay. I am Abhijit Das. My title of the paper is Water Criteria Evaluation for Drinking Purposes Mahanadi River Basin, Odisha. I am from Sivaraman Global University, Bhubaneswar, Odisha. These are the contents: highlight, abstract, introduction, study area, methodology, result discussions, conclusion, and references. These are the highlights and abstract will be studied in after course of point of view after the result discussions. Generally, rivers are one of the major sources of fresh water for human beings. As I am from Odisha, I use my lifeline of Odisha, that is Mahanadi River, and I have taken 3-year data period 2019-2022 from 19 different sites from 20 water quality parameters. As in Mahanadi, from the recent papers of Mohseni, Mahsood, Sunita, Mata, Yakub, there are few studies which have done, but on the integrated approach of 6 indexes of water quality with GIS with multivariate techniques. These haven't been used in Mahanadi River, so I have tried my level best to complete this. And what are the analysis I have got? I want to show that. Next slide. This is the study area, and from the research papers of numerous Chakrapani, Das, Nanda Tiwari, Radhakrishnan, Panda et al. 2022. There Mahanadi, they have just carried out the basins pollution, water pollutions, criteria of pollution sources, contaminations, industry polluting sources. These I have done, but the integrated approach of Mahanadi using 6 water quality indexes with multivariate techniques haven't been used. And these are the stations of 19 stations: Sundargarh, Jharsuguda, Brajrajnagar, Sambalpur, Dhamma, Ulunda, Sonpur, Narsinghpur, Tikarpada, Cuttack, Paradeep. Up to the full stretch of Mahanadi, whatever the districts or stations I have used that lies on Odisha, I have taken and I have done the analysis. These are the methodology. I have used 6 water quality indexes. One is weighted index method, Canadian index method, Council of Ministers water quality index method, SPI synthetic pollution index method, and from one of the research paper is Mutlu 2019, and NPI method I have used, numero pollution index. This paper I have this techniques I have used from that Ujjain city in Madhya Pradesh, that research paper in 2022. For the OIP overall index of pollution, Deshpande paper I have used, and comprehensive pollution index I have also used to analyze the result. Correlation hierarchical cluster analysis from SUNA 2020. It's a based of method that we have to categorize the stations based on the pollution sources. It can be of moderate, low, or high. But in PCA, whatever the stations we have categorized in hierarchical clustering analysis, in PCA, what are the contents, what are the contribution of the each parameters, and what are the limits, what are the values, depending upon that the pollution sources are originating. And we have used that in principal component analysis from the paper Shah and Paul, Vati et al. 2019. These are the result discussions. I have taken 20 water quality parameters, and these are the spatial distribution maps using IDW techniques on the paper referenced by Chobuk. In Tigris River, they have done in IDW technique, and also in Parag and Jahalka 2015, they have also adopted the same method in IDW technique. And these are the water quality parameters. I have done the spatial interpolation maps of each parameter, and from that parameter, we have found that TKN and TC have exceeded the limits in all the stations. Therefore, this number of parameters does not depict the index value. So I have calculated the each index value to know the extent of deviation of each parameter. So I have used weighted arithmetic water quality index, CCME, SPI. From the water quality index, I have asked excellent to very poor category got 3 samples belongs to excellent, 13 fall in good, 2 in poor, and 1 in similarly CCME I have got 34 to 84 good to fair, and SPI got good to very poor, and obtain OIP also excellent to polluted, and CPI comprehensive pollution index sub clean to seriously polluted category. In the above 6 index method, we have found that the Cuttack downstream, Paradip and Chaudhar of Odisha belongs to polluted category. From the comparison of different methods for the common stations which are prone to pollution, these are the Cuttack downstream, Paradip and Chaudhar. We have found that. For that, these are the index values I have just plotted, and in the shown each individual stations, what are the values of each index. Next is this is the percentage distribution of each samples, that is good, fair, poor on individual index calculations map. After that, this is the spatial interpolation method where I have shown that each index map, whatever the analysis and what are the classes, excellent, poor, these are the zones I have divided and depicted in that GIS interpolation format in ArcGIS 10.5. This is the correlation of parameters. I have taken 20 parameters. So in the most positive correlation is BOD and TC. And from that, due to the decomposition of organic matter, TH also, TH chloride sulfate also positive relation because their contribution is more also, and EC SARB also contribute a major part of EC. From the correlation matrix, we have found that TC, TKN were found as the principal factors influencing water quality of Mahanadi. Other parameters are also influencing a station 9. Station 9 is Paradip. Next, I have used the cluster analysis, whichever zones which are prone to low pollution, moderate, and high. So from cluster analysis, these are the parameters, and these are the stations you are seeing. And the cluster 1, you have seen that 17 sampling stations which are gone regarded as low pollution zone. It can also be validated with the index method where that
We cannot hear you.
Mr.
Yes.
Das, so you
yes, sir.
please unmute yourself. Yeah,
Yes,
now
sir.
it's clear. Yeah.
Sir, previously it is unmuted. Okay, sir. Sorry, sir. Cluster 1 is 17 sampling stations. In that also, different water quality index method also resulted the same good quality. So it is comes under low pollution zone. From the cluster 2 also, it regarded one station Cuttack downstream, that is also poor water quality due to the high TC, TKN and iron. And cluster T contains one station, the station 9 is Paradip, and the high pollutants are EC, SAR, TDS, TH, chloride, sulfate, TKN, iron and TC. And next is next is PCA, principal component analysis. These are the parameters. You can see that these are the parameters. This is the IGN value, variability and cumulative. And the first PC, 93.915% it shows. This is the high concentration of TH, sulfate, EC, TDS. Second PC, 11.186. Third PC, 11.186. Fourth PC 8.6, and finally 5 PC 5.96. This is the IGN value you can see, and the cumulative variance you can see, and this is the loading plot of all parameters depending upon the concentration of the component loadings of each component done by PCA. This is the factor scores. This is the most important analysis done by Chidambaram in 2008. There I used in Mahanadi Basin. Factor scores can be calculated on the basis of the two methods, weighted least square method and the regression method. From that analysis and the 5 components reveals that mineral components, domestic industrial waste, municipal domestic waste, wastewater pollution, waste from fishing activities and mining activities are the major causes for the polluting of Mahanadi River to the till extent. Next is, this is the interpolation map of each factor score you can see. And the conclusion is, in Mahanadi River, the present study, I've used 6 water quality index with multivariate techniques, CA and PCA. The river is generally slightly alkaline nature. We have found from the analysis of physiochemical parameters, the TC and TKN are the above the exceeding limits of WHO 2011. And the results of different index reveals that 84.21% excellent to good, CCME reveals 73.68, SPI removes 89.47%, and NPI, OIP, and CPI together promotes 84.21 of samples belongs to excellent class. In that condition, overall, the 6 methods resembles that Katak station, Paradip station, and Chaudhar are the polluted zone and their needs require treatment. Next is correlation matrix and the index methods. They are also found that these 3 stations are also providing cascading effects on the health of the ecosystem. And in terms of PC also, 5 PC has been extracted and that contributes organic pollution, agricultural waste, rainfall runoff, and riverbed erosion. The water quality values deduced in the study could be monitored in depth across larger spatial temporal scales with integration of biological entities, and subsequently further research work can be done in deep learning approaches, including artificial intelligence, to control water pollution. References, thank you.
Thank you, Mr. Abhijit Das, for this interesting presentation. The session is now open for question and answers.
Thank you, Mr. Das. This is a very good piece of work. And I think you would have got 2 or 3 papers out of these results. And the main heartening fact is that most of the water, most of the indexes are showing 80% or 85% of the water is in good category.
Yes, sir.
This is really very heartening to note that.
Sir, actually, yes,
very negative results and and we are seeing that most of the water is belonging to the good category. So this is heartening to note that. This is a very good piece of work. I congratulate you. Well done.
Sir, can I say something, sir? Sir,
please go ahead.
Sir, sorry, sir, I didn't aware that my voice is not audible.
No, you were muted only in that component analysis. Only on that slide it was muted. So you just where you had left.
Okay, thank you so much, sir. I'm just learning this and also adopting new techniques also in comparison of different parameters, and also I am using that ANN model. As Subham Singhal sir told that PPT must be 10 minutes, so I have tried to be fast.
No.
Thank you so much.
This is a very good piece of work.
Thank you so much, sir. Means a lot, sir. Namaskar.
Thank you. Namaskar.
Thank you so much, Mr. Abhijit Das. Thank you for your presentation. So our next presentation is paper ID 173.
So is my screen visible?
Yes, your screen is visible. You can start your presentation and limit yourself to 10 minutes.
Okay, sir. A very good afternoon to everybody present here. I am Harshita Mokha, a BTech IT second year student at AUP India. First of all, I would like to thank my supervisor, Dr. Natasha Steve, ma'am, for guiding me to the best throughout my journey of writing this paper. I would also like to express my gratitude towards the panelists and organizers for giving me the opportunity to present my work in front of you all. The title of my paper is Challenges to Implement Artificial Intelligence for Environmental Sustainability. In this study, we conducted a comprehensive literature assessment of highly influential works that focus on artificial intelligence and its advantages for reaching the Sustainable Development Goals and environmental sustainability. This work brings forth the challenges to implement artificial intelligence for environmental sustainability. The findings reveal that artificial intelligence is dependent on complex data, which is at risk due to security threats. These are the contents I'll be covering up in this presentation. Environmental protection is one of the most important and frequently debated topics in contemporary times. The environmental crisis has become a global issue, and every nation is in a catastrophic situation. Whether we are talking about climate change, pollution that leads to damage of the ozone layer, acid rain, or the greenhouse effect, extinction of species, or decline of biodiversity. Climate change, pollution, global warming, increased carbon footprint, deforestation, loss of biodiversity, ozone layer depletion, species extinction, natural resource depletion are few of the major concerns that are widely acknowledged to be a part of environmental catastrophe. Sustainable development can be achieved and the environment can be protected with good technology applications. The goal of modern ecological advancement is to employ green technologies to monitor, protect, and minimize the negative effects of technology on the environment while addressing a variety of environmental problems such as global warming, carbon emission, and energy conservation. The use of green technology may have significant advantage over the long period. Progress in terms of technologies has made the SDGs implementation considerably easier and more attainable. In addition to exploring the obstacles that prevent the use of artificial intelligence for environment sustainability, this study assesses the current state of the art surrounding these applications. Considering the relevance of the topic, there is a need to analyze the role of AI in environmental sustainability. The methodology used for systematic literature review is the PRISMA 2020. The PRISMA 2020 flow diagram consists of a checklist which specify the inclusion and exclusion criteria for the review and how studies were grouped for the synthesis. This is so that systematic literature review may aid in the exploration and assessment of the research field. We found the latest papers aligned towards the topic from Google Scholar, IEEE, Springer. Majority of the papers were from the year 2022 and 2021. We then critically appraised the quality of studies and then synthesize and summarize the findings from included studies. We reviewed total of 32 influential literature papers in a study which were aligned towards our topic. Some of them explored the significance of artificial intelligence in environmental sustainability, which focus on catastrophes like biodiversity, energy, and water conservation, reduction of carbon emissions. A work in literature discusses the role of AI in agriculture sector, and AI can be beneficial in solving problems which a farmer faces, ranging from sowing seeds to the perfect amount of pesticides to be used. AI can aid in traffic management, water conservation, species extension, and water and energy conservation, reduction of carbon emissions. A work in literature also discusses the role of AI and so on. We reviewed a number of studies and identified the challenges that the authors faced during the research. Challenges such as risk for data being hacked is the most major concerning challenge. Next challenge, data complexity. The environment data is very diverse in nature, and the nature of its storage and retrieval is very different. Also, the data may be distributed across a variety of geographic regions, thus making it a key challenge in finding insights for the data. Another challenge is data dependency. Model training in AI uses past data, and with the evolving nature of AI and variability of human behavior, this dependency poses challenges. Past data reflects ages of information, which makes it hard to predict the future. Inadequate measurement, measuring and monitoring of interference in environmental sustainability is very difficult and mostly complex to perform. Unequal access and benefits. In the agriculture sector, even if some farmers are able to cost effectively improve their own businesses, mass use of AI in farming might still lead to increased inequality and capital concentration. Moving on to the application of AI in environmental sustainability, AI advantages include improved environmental governance, industrial environmental performance, risk reduction, and safety. Application of artificial intelligence have considerably advanced over the last few years, and they are now being used to support environmental sustainability. To anticipate, monitor, and protect ecological services, AI may be employed in predicting energy production, distribution, operation, maintenance, and biodiversity. Several apps have also been developed to leverage artificial intelligence, such as Orico, Capture, Iris Cycle, Carbon Footprint, and CO2 Tracker. To conclude, the purpose of the study was to evaluate influential literature for identifying the challenges that hinder AI implementation for environmental sustainability, and also to see the substantial contribution of AI to achieve environmental sustainability. It is found that there are many studies which are focused on sustainability in the areas such as biodiversity, species extinction, transportation, climate change, pollution control, and so on, which concludes the major issue we face in implementing AI in environmental sustainability are the challenges such as data dependency, complex nature of data, risk of hacking, inadequate measurements, and many more. There is much more effort to be done in this area to produce meaningful outcomes so that our current and future generation may live in a safe environment. In the actual world, new tactics and AI-based advantages can be deployed. For further study, ranking of the challenges identified can be done using AHP, and we can identify which challenge is hindering the implementation of AI for the most. To make any major progress toward environmental sustainability, actions must be taken, measured, and monitored in a timely, precise, and accurate manner. These are some references. Thank you.
Thank you, Ms. Harshita, for your wonderful presentation. The session is now open for question and answers.
Thank you, Ms. Harshita. You have touched upon a very relevant topic, challenges to implement artificial intelligence. But I would have liked it more if you had discussed, okay, you have told us the challenges. How do we go about solving these challenges? You have briefly touched upon that.
Yes, sir. I'll do more work on it in the upcoming years.
Exactly. I would like that. Thank you.
Thank you, sir.
Any questions from participants? Okay, so with this we concluded this technical session on recent developments in environmental engineering. I thank Dr. Amardeep Singh, sir, and all the participants. And I would like to invite Dr. Amardeep Singh, sir, to conclude this session.
Thank you,
Sir,
Dr.
would you like to say something about the session?
Sure. I would like to say something. We have had 7 very interesting and very wide-ranging presentations in this session. The first presentation was on drinking water quality assessment in Kabul, Afghanistan, in which we had about 500 square kilometer area, and we had taken so many samples, and we had seen that 13 parameters are exceeding the WHO guidelines. And finally, we got some metrics of correlation coefficients. And we have been promised by the speaker that this matrix would be taken further to, they would be looking at some equations and would be implementing some models. The second paper was on comparison of performance of ANN and MLR, which is multiple linear regression in groundwater. And this is also a very good paper. And we found that MLR was performing better than ANN for the case of electrical conductivity. And this study can be extended for other parameters of water quality also. Then the third paper was on sources and toxicity assessment of cyanide from iron and steel industry. And this study has been mainly focused on iron and steel industry, and maybe this study can be carried out for other industries also. The next was a very, very interesting topic, potential of individual leaf traits and leaf associated microorganisms in the removal of particulate matter. This is again a very good, very timely piece of work. But now we would like to get some numbers. Like we say that bacteria, fungi, they would increase the PM reduction. Then by what amount, by what numbers? So this would be a very good work. The next paper was on assessment of fluoride in groundwater and its correlation with various physicochemical parameters in Bihar. This was also a very good piece of work, and the results are being used to reduce the fluoride concentration by employing suitable techniques. The sixth paper was on water criteria evaluation for drinking purpose in Mahanadi River Basin, Odisha. So various water quality indexes were calculated, and it was really heartening to note that most of the indexes were showing that the water quality falls in the good category. And then this method can be used for other river basins also. The last paper was on challenges to implement artificial intelligence for environmental sustainability. We listed some of very important challenges. What is needed is how to address these challenges. So we have had 7 very, very good presentations, and I hope that all of you have benefited immensely from all of them. Please join me in giving a huge round of applause to all the speakers for their excellent work. Now, I would request Dr. Singhal to take over the proceedings from here. Thank you.
Thank you, sir, for your wonderful remarks and constructive comments. I'm sure participants will get benefit from your suggestions. And I hope participants will incorporate the suggestions and comments of Dr. Amardeep Singh, sir, in their research work. I thank all the participants and Dr. Amardeep Singh, sir, for this technical session. Thank you all.
Thank you.
Thank you, sir.
Hello, sir. Can I end this session, sir?
Yes, sir. This session can be ended, and now we will move on to next session. That is track 8.
Track 8. Okay. This is different link, na, sir?
No, same link. Same link.
Same link. Okay, sir.
Same
Okay.
link, and
Same link.
Dr. Kedar Sharma
Okay,
is
sir.
session chair for this as he joined. Hello, am I audible?
Yes, yes.
Okay.
Now you are audible.
Okay, so we are waiting for our session chair, Dr. Kedar Sharma. He will join soon, and then we will start. Okay, so Dr. Kedar Sharma is here. So this is our technical session number 8, which is based on recent developments in energy conservation and sustainability. Our technical session chair is Dr. Kedar Sharma. He is working as associate professor in the Department of Civil Engineering at J.K. Lakshmipathy University. He has completed his MTech and PhD from IIT Kanpur in 2005 and 2013 respectively in hydraulics and water resource engineering. He has graduated from Engineering College Kota in the year 2003, and then he has served at BML University, Gurgaon, and Swami Keshavanand University of Management and Technology, Jaipur. And his research areas are in the field of optimum water resource management in Chambal Basin and possibility of inter-basin water transfer from Chambal Basin to Banas Basin. He has also taken various consultancy and research projects at IIT Kanpur during his PhD. I welcome Dr. Kedar Sharma, sir, to this session, technical session. And now we'll start our presentation.
Thank you, Subham, and welcome. Very good evening from my side to all the participants. So now we can start our session.
Thank you, sir. I welcome all the participants. So our presentation IDs for this session will be presentation ID 32, 34, 36, 38, 43, and 46. So I would request presentation ID 32 to please start their presentation.
Thank you so much, sir. Very good afternoon to everyone. Hi, I'm Soumen Ghosh. I'm doing my PhD from Tata Institute of Social Sciences, Mumbai. Just a second.
I would request that you please limit your presentation to 10 minutes because we are already out of time.
Okay, sir. Okay, sir. Thank you. Thank you so much for giving me that opportunity to present my paper in that conference. So today my paper was on a bibliometric analysis of social life cycle assessment. The paper is constructed with introduction followed by literature review, problem formulation, methodology, result and discussion, and conclusion. So first couple of minutes, I will talk about the background of that social sustainability, and then I will get into the main topic. So in the 1987, when Brundtland Commission report came out, they talk about the sustainable development. So it's sustainable development that meets the needs of the present without compromising the ability of future generation to meet their own needs, that you all know. During that phase, they talked about three pillars of sustainability. One is ecological or environmental, economic, and social. In the initial stage, the researchers and practitioners emphasized on ecological and economic sustainability. And after the 2 decades of Brundtland Commission report, researchers and practitioners finally recognized the relevance of the social pillar of sustainability, because they realized that without these three sustainability pillars, it is not possible to achieve a overall sustainability. So in the last 2 decades, social sustainability has gotten a lot of attention from policymakers and researchers. However, like economic or environmental sustainability, social sustainability is, I mean, the measuring of social aspect is not as, it's not an easy task. To assess social performance, a variety of measures and approaches have been created. Finally, in 2009, United Nations Environmental Program and the Society of Environmental Toxicology and Chemistry have developed a LCA-like framework, that life cycle assessment-like framework, to address this issue. This new methodology is the social complement of the environmental life cycle assessment. It compromises the social impact of products' whole life cycle, from raw material extraction to disposal. Despite the fact that the methodology is new and still it is in the incubation stage, it gained a widespread acceptance among the academics and practitioners due to its inclusive nature. Now, I just give the definition of social life cycle assessment. So basically, social life cycle assessment is a social impact assessment method that aims to assess the social and socio-economic aspects of the products and their positive and negative impact along their life cycle, encompassing extraction and processing of raw materials, manufacturing, distribution, use, reuse, maintenance, recycling, and final disposal. As this methodology is very new and also a unique framework to assess the social aspect of sustainability, it is in developing stage, because if we see the guidelines given by the UNEP SETAC, so we can see there are five stakeholders are there. 6 subcategories are there, impact categories are there, and it varies across the product, across the geographical boundaries, and so on. So in this study, we have just we are just presenting a bibliometric analysis by using the bibliometric data, and from the literature we have seen there are 2 types of research are available. So first type mainly addresses the methodological discussion. It may be the new methods, it may be the modification of the existing guidelines given by the UNEP, and the recent articles and the recent articles attempted to combine sometimes social and environmental life cycle assessment, sometimes social and the organizational life cycle assessment, and so on. And the second type of studies focuses on the case studies. So basically, they talked about the new methodology or new some modification of existing methodology, and they just conducted a case study. So these two types of studies we have seen. So our study examines the existing literature with the goal of presenting a comprehensive picture of social life cycle assessment based on bibliometric data. So this research seeks to illustrate the trajectories of the comparatively new field as well as potential research gaps in the existing literature. So given this that aforesaid objective, we have four research questions. So first is what is the direction of the research in the field of social life cycle assessment? Number two, which are the major contributing journals in social life cycle assessment domain? Number three, who are the eminent contributors in the field, majorly with whom they are collaborating? And number four, which are the most consecutional scholarly works in that realm? So to identify the most relevant papers, we have selected only journals article for that analysis. To fulfill the research objectives, we have set some prerequisite criteria to get the optimum results and reduce the likelihood of biases for our bibliometric analysis. So, and we have primarily ignored the gray literature in our criteria. That means the master's thesis or some thesis or substandard journals we have ignored. Okay. So, so primarily for that bibliometric analysis, we have selected articles using some specific keywords. So here you can see in the step 2, the social life cycle assessment or SLCA or S-LCA or social LCA. We have broadly used the Web of Science core collection database to find the most prominent pertinent articles. In the first stage, we only use keywords. In the next stage, we have selected the language and type of publication for screening. In the past, in the last phase, we did a manual screening for our article selection. After all these filters, we finally have 135 journal articles for our bibliometric analysis. So now we will go into the final result. So first we will start with the descriptive analysis. So here in figure A is discussed about the yearly trend of publication of work. So here you can see in 2008 that starts with one article. In 2009 again it's a single piece of article on social life cycle assessment. And in the phase 2017-18, there is an upsurge. And the average number of publications between 9 to 10 articles per year from 2008 to 2022. So in the second picture, we can see in the figure B here these are the top 5 SLCA contributing journals. And the significant publication source in that domain is the International Journal of Life Cycle Assessment. The International Journal of Life Cycle Assessment has produced 71 papers overall, followed by the Sustainability and the Journal of Cleaner Production with 19 and 13 respectively. Of the total number of papers available, top 5 journals account for 83%, 112 articles out of 135. Apart from this, many journals have made a tiny proportion of contributions to this particular domain. Now we will enter into the main bibliometric analysis. So here we can see, as I mentioned in figure 2, there are top 5 journals. So here we can see table 1 describes the top 5 contributing journals for SLCA with the number of total publications, H index, total citation, and average citation per article. So again, you can see the International Journal of Life Cycle Assessment, which is contained with 71 total publications on social life cycle assessment related literature, which has the total number of citation is 2636, and also the average citations per year is 37.12, followed by the sustainability, which is 19 total publications, and the average citations per article is 11.31. Journal of Cleaner Production, Journal of Industrial Ecology, and Science of the Total Environment. So in the next section we will see that we have done a affiliation analysis. So here we can see the top 5 affiliating universities are Technical University of Berlin, which has owned total 13 number of articles out of 135. The second highest institute on that list is Delft University of Technology, which is also very close to the earlier one with 12 publications. The Technical University of Denmark, University of Calgary, and the University of Coimbra holds 9 publications each in this group. Unlike the University of Calgary of Canada, the rest of the universities in the top 5 contributing institutions are situated in Europe. So there is a clear dominance of European universities and affiliations we can observe. Similarly, that table 3 shows about the top 5 contributing countries in the SLC area. In Germany on the top with the 17 total articles, which holding 13% of the total output, followed by Italy, Netherlands, Sweden, and Spain. This table also shows the country of residence of the author's affiliation. So like earlier, this picture also shows a clear dominance of European countries. If we see more aggregate level in terms of the 5 continents, the distribution of Europe is 64% with 87 articles on social life cycle assessment out of 135. Asia, and then Asia 16%, North America 13%, South America and Oceania is 5% and 1% respectively. So now we can see to strengthen this analysis, we can say that figure C portrays the interrelation of co-authorship network in terms of countries. Here we can see most of the collaboration held with different institutions in Germany, followed by Italy, Netherlands, Sweden, and Spain. Okay. So now coming to our research question 2. So, to understand this.
Sorry to interrupt, Mr. Ghosh, but
yes,
it is requested to please conclude.
Okay. Okay. How much time I have, sir?
You have already taken around more than 13 to 14 minutes.
Okay. Okay. Sorry. Sorry. So basically, so here we can see the trend is same. The most of the authors, the table 4 and table 5, we can see the most of the authors there from the studies were based on European countries, which is already the developed nations. So this table 4 is discussed about the most influential authors on top top 6 authors we have discussed, and table 5 discussed about the influential articles with their total citation and total citation per year. And this is a very interesting picture, which is which talked about the post-citation analysis of the authors, where we can see the Jorgensen, Dreyer, Norris, they are holding the most, I mean, the co-cited articles in that particular domain. And this is a word cloud analysis of authors based on authors keyword, where we can see the sustainability, that social LCA, SLCA, social life cycle assessment. This term has been used repeatedly in the literature. So in the concluding remarks, we can see that International Journal of Life Cycle Assessment is the major source of this area, that there is a clear dominance of European countries in terms of affiliation of the authors, the co-authorship network of countries. Then most of the collaboration has done in Germany, Italy, Netherlands, Sweden, and Spain. So one of the reasons for that dominance of a particular continent is when the task force has, prepared, the most of the members are primarily from Europe. So this is the main reason for that. Article written by Jorgensen, that is globally most cited article on social life cycle assessment. So my suggestion from that study is apart from the Europe and North America, more studies required to other continents as well. Although there is an upsurge in Asia. Asia is very big continent, and more studies will improve the acceptability of these studies, and it will eventually develop the work ambience and the social aspect of sustainability better in the near future. Thank you so much.
Thank you, Mr. Ghosh, for this wonderful presentation. The session is now open for question and answers. I would request Dr. Kedar Sharma, sir, for their comments, and if any questions are there.
No question from my side. Means the is a comparatively good work, and almost it is a new work for me. So we can start with the next presentation.
Thank you so much, sir. Thank you so much.
Any questions from participants? Okay, so we will move to our next presentation, paper ID 34.
The old one is the paper ID is
32.
32. That was 32.
Oh.
Now this is 34.
okay.
Paper ID 34. I guess there is some technical issue with paper ID 34. Can we have paper ID 36?
Yeah, yes, sir. Am I audible?
Yes, yes, you are audible.
Okay. Is this screen visible?
Yes, your screen is visible. You can start your presentation.
Okay. So good evening, everyone. My name is
Just a
Pooja
minute. Just a minute. Sorry to interrupt. Paper ID 34, I would request that you please resolve your technical issue, and next will be yours presentation. Meanwhile, we will have paper ID 36. You may resume.
Okay.
Paper
So,
ID
good evening.
34. Please, Pooja, one second. Paper ID 34.
Yes, sir, yes.
Sir, actually,
Please.
paper ID 34 is having some technical issue.
Yeah. Just to just to complete me, just 34. Just discuss with the other friends, and then means you can join in the after this presentation or after that presentation. So the next presentation also, no issue. Okay. Yeah, Pooja, you can continue.
Okay. Okay, sir. So I'm here to represent my paper whose title is Exploring the Role of Hydrogen Energy Towards Sustainable Energy System of India. So the content of the paper is like this. First of all, introduction, then methodology, then about its role, production process, comparison, some scale and cost analysis, then storage and utilization, and challenges and conclusion. So the principal driver behind a sustainable energy vision of our future center on the need to reduce global carbon dioxide emission and improve local air quality, and also to ensure energy security of energy supply. Now, hydrogen is a versatile energy carrier. Hydrogen is an attractive alternative fuel. Unlike coal, gas, or oil, hydrogen is not a primary energy source. Rather, its role mirrors more closely that of electricity as secondary energy carrier, can be obtained from diverse resources, both renewable resources and non-renewable resources. It can be stored as a fuel and used in transportation and distributed heat, internal combustion and engines or turbines, with the only byproduct at the point of use of being water. It can be storage medium for electricity generated, and it is a genuinely green fuel. It is a sustainable energy economy, generally placed under the umbrella of hydrogen economy. Coming to the next point, to understand the hydrogen, we have to understand some basic background. So there are 9 color codes for hydrogen. Green hydrogen is produced using renewable electricity and water electrolysis process. Here the green refers to the fact that no carbon dioxide is released during the manufacturing process. Blue hydrogen is produced from fossil fuel. Furthermore, carbon dioxide is captured and stored underground. Here no carbon dioxide is emitted during blue hydrogen synthesis. The process of producing gray hydrogen for fossil fuel is known as steam methane reforming, and here carbon dioxide is produced and ultimately released into the atmosphere during this process. Coal is used to make this black or brown hydrogen. This black or brown represent the bituminous coal and the lignite coal. Here the coal gasification is a method for producing this type of hydrogen, and it is extremely polluting, with carbon dioxide and carbon monoxide produced as byproducts and released into the atmosphere. The thermal splitting of methane via methane pyrolysis can be used to extract turquoise hydrogen. Well, this is still in a very new stage. The process removes carbon in solid form rather than carbon dioxide gas. Again, purple hydrogen is produced from combining nuclear power and heat to split water using thermal electrolysis. Pink hydrogen is produced by electrolyzing water with nuclear power, and red hydrogen is produced by catalytic splitting of water with nuclear power, thermal as an energy source. And the last is natural hydrogen, which is referred as the white hydrogen. Now, this is the basic problem formulation. I would like to mention my research question, like what is the hydrogen energy system and how it can be produced, how much the system is going to affect the environment, is the system is scalable as well as cost effective, and what are the challenges for effective hydrogen storage and utilization. Also, what are the policy gap on hydrogen energy transition for future. About the approach and methodology for this paper is basically based on systematic literature review that analyze the hydrogen energy system and its all possible challenges and opportunities related to energy transition. The focus of this paper is to deliver a clear understanding of hydrogen energy and all related concepts so that we are able to analyze the current gap leading to achieve the 2030 hydrogen energy target. So I have differentiated in 5 steps. My first step is to determining the research question, which I already mentioned in the previous slide. Second step is locating pertinent studies or articles where the sources were implemented in electronic database such as Google Scholars, Scopus, Web of Science, etc. Also different articles from different think tanks like NITI Aayog, TERI, so many publication, newspaper, etc. Next step is to research selection where duplicate and irrelevant articles are removed throughout the research selection process. Then the step is collecting a summary of the findings, and after that I summarizing the conclusion, and this section will include the result of the review which mention the gap, challenges, opportunities. Now here is the role of hydrogen energy. The figure shows that hydrogen has having multiple linkages to end user, hydrogen production, distribution, and delivery, as well as hydrogen storage and utilization are all part of a typical hydrogen energy chain. The energy chain for sustainable hydrogen energy would involve the collecting of sunlight or other energy source to create hydrogen as the energy carrier, its storage and delivery, and its conversion to power at an end tool using either fuel cell or combustion. Coming to the next slide, these are the production methods of hydrogen energy. The most common method is a steam reforming method, which is primarily from methane, and it is the cheapest source of industrial hydrogen at the present time. This method is used to produce nearly half of the world's hydrogen. Well, this process involves heating the gas between 700 to 1100 degrees Celsius in the presence of steam and nickel catalyst, and it follows breakdown of methane molecule into carbon monoxide and molecular hydrogen. After passing this steam over iron oxide and other oxide, the carbon monoxide gas can undergo water gas reaction and hence produce hydrogen. And here is the two basic reactions. So when the waste carbon dioxide in discharge into the atmosphere, the hydrogen produced by steam reforming is referred to as gray hydrogen. And when the carbon dioxide is captured and stored geologically, it is referred to as blue hydrogen, as explained in the section of carbon capture and storage. Second process is partial oxidation. It's an exothermic reaction in which the reformer hydrocarbon, natural gas, and oxygen are partially combusted, yielding hydrogen-rich syngas. And it is the second most significant process and absorbs all liquid and gaseous fuel, including sulfur-rich material like heavy oil. The fundamental chemical equation is also given here. Here in this process, in the end, emit carbon monoxide in addition to carbon dioxide, which is considered as the major disadvantage. India is concerned about the status of this process, which is currently limited to the laboratory scale. Third method is coal gasification, where the CO2 is the most significant greenhouse gas and the world large emitter. Here, the synthane process and the CO2 acceptor process are both used to generate hydrogen from coal. Carbon monoxide, carbon dioxide, and hydrogen are the gaseous product of coal when it reacts with steam at 450 psi to 800 to 900 degrees Celsius. Methane is produced in a small amount. After that, methanamide or potassium hydroxide is used to remove here carbon dioxide from the final gas. And at the last, 97 to 98% of the gas is pure at the end. And also here the byproduct is carbon dioxide. Next step, next method is electrolysis, and which is the breakdown of water into two compounds, oxygen and hydrogen, by passing electric current through it. However, because the input energy is electricity, this process is very expensive. And this process is very popular because it is the only one that doesn't require the use of fossil fuel and also has high quality and can be done on both small and large scale. Electrolysis produces carbon dioxide only when power plant use fossil fuel to generate electricity. And here one point is important, that here in electrolysis, the roots are solar photovoltaic power or wind power or hydropower. Next method is pyrolysis, which is used to produce turquoise hydrogen. In this process, they remove solid carbon from natural gas and stored in the landfills. Last method is through biomass gasification, and here the main method for producing hydrogen from biomass is through various thermochemical routes, which include steam gasification, superficial water gasification, and fast pyrolysis. And because of its higher efficiency and hydrogen air, gasification is seen as more compelling in industrial production than pyrolysis. Now, overall, if we compare all these methods, we have certain advantages and certain disadvantages. In case of partial oxidation, it is pure exothermic reaction which does not require heating and also economically promising. But here the production rate is very slow and it's very difficult to control that reaction. If we talk about the steam reforming, it is well-established technology. Thermal efficiency is also very good and also produces 99.9% of pure hydrogen, but it consumes very high energy and operating cost is also very high. For biogas gasification, it is high efficiency, environment friendly and economically visible, but the reactor cost is very much high. For coal gasification, it is thermally efficient, cleanest process to yield hydrogen, but the drawback is due to it occurs groundwater contamination. For pyrolysis, it is relatively lower operating cost, but the drawback is further purification is required to eliminate the output gases. For electrolysis, it is completely clean process, but the drawback is the production cost is very high and lower efficiency than carbon reforming, also higher consumption of electricity takes. Coming to the next slide, this is the scale and cost of cost of hydrogen production. If we talk about the electrolysis, it produces green hydrogen. So to produce 1.1 ton of green hydrogen, we require 4 times more water and much more electricity, and the production cost is also very high. But here the byproduct is oxygen, which is very clean and doesn't affect the environment. Second process is steam methane reforming and water gas method. Here, 1.1 ton of gray hydrogen is produced, but the byproduct of carbon dioxide is released into the atmosphere, which creates pollution. Also, here the input amount is much more than the electrolysis process, and the cost is bit low. Third is blue hydrogen. So to produce 1.1 ton of blue hydrogen, we require almost 3 times more water and 3 times more methane and also heat. But here the byproduct is 5.5 times more carbon monoxide, and after 70% of carbon monoxide capture and sequestration system, 1.5 ton of carbon dioxide are released into the atmosphere and rest in the underground injection, and the cost is also very high. So this process is not so much feasible and still it's very new stage. Last process is methane pyrolysis. This process is used to produce turquoise hydrogen. So to produce 1.1 ton of turquoise hydrogen, we need 4 ton more methane. And here also the carbon is produced and the solid carbon is going to separate and used to landfill. Here also no pollution, it's also a pollution free and the cost is also high. So if we're ranking on the basis of cost, clean and scale, we see that green hydrogen is the first rank. After that, gray hydrogen is the last one. Now the hydrogen storage and utilization. So one of the most important and technically challenging.
Sorry to interrupt, Ms. Pooja, but can you please conclude?
Okay. So the operating requirement for the ideal hydrogen system for transport application, we have multi-cycle reversibility of hydrogen, temperature maintenance of 50 to 1508 degrees Celsius, fast hydrogen uptake and kinetics. And if we because hydrogen is a gas, so it's very difficult to use in portable application. And there are essentially three methods for reducing the mass of hydrogen to conservative and transportable structure, and these include metal hydride, liquefied hydrogen, and compressed hydrogen. So this cycle represents the hydrogen utilization. Now coming to the challenges, we have some challenges. We have safety challenges because hydrogen have high flammability, high pressure, and low temperature. Some social challenges like psychological and social issue with the adoption of hydrogen economy. Also, there is a low confidence among the consumers for the this new technology. Environment impacts are so high because so much carbon dioxide is released into the atmosphere. We have challenges in supply chain management. We need some fabrication of electrolyzers, also financial stability of green hydrogen industry, high technological cost, and water availability. Water availability is the most important because it takes almost, if we produce 1 kg of hydrogen, we need almost 9 kg of water, 9 liter of water. So water is the major challenge. Now the conclusion is green hydrogen has risen to prominence as a game changer among net zero energy. It can be viewed as a supplement to its option rather than viewed as a stand-alone solution because it has its own set of limitations. Apart from electrification and battery storage, its intrinsic chemical property varied in uses and
Pooja?
Yes, sir.
Yeah, there is no need to read down all these things. We know that these are what are the major things.
So this is my conclusion slide, and these are the reference. Thank you.
Okay. So Pooja, in one table you give that means what is the cost comparison? Is this cost is for the India or for other countries?
No, sir. It's overall cost. Other countries, USD. It's not for India.
Price is you mentioned for the means say like in dollar means dollar is also means the available and acceptable in India also.
No, sir. It's not for India. I have seen a paper where it's for US.
Yeah, this cost is
I
for
haven't got cost in regards to India, like all the methods and all. So that's why I mentioned this.
Okay, so you have to mention that in your thing that this is the price for the US market.
Yes, sir.
And what is the means the did you know that in India also there is some cars is launched with the hydrogen fuel?
Yes, sir. Yes, sir.
Okay. And what is the most important challenge with the hydrogen?
Sir, I think most important challenge is the storage. Storage is the yes, sir. Storage is the most challenge because we have to develop the fuel cell, and also we have to develop because its flammability is very high. It requires some particular temperatures. Also, sir, it's very difficult to fuel station development is also very difficult challenge. And yeah, these are the things.
Okay.
Am I audible? Should I go?
Yeah. Is there any other question from participant side? Okay, so now we will move to paper ID 34.
Thank you, sir.
Thank you, Ms. Pooja. Paper ID 34, you can now present.
Is my screen visible? Am I audible?
Yes,
properly?
yes, your screen is visible. You are audible. You can start.
All right. So the title of my paper is Establishing a Preliminary Understanding of Loss and Damage in India in Case of Floods in Assam. My name is Soumya, and I have completed my master's from Climate Change and Sustainability from TIS. So the content of the presentation is as follows. So I would like to start by mentioning how there has been a dramatic increase in extreme events due to anthropogenic climate change, which is basically because of the carbon dioxide emissions that we have emitted. And this has been accepted by multiple scientific organizations like the IPCC and UNFCCC. And the second point is that there has been minimal action on loss and damage, which is basically something caused because of climate change and the extreme weather events that are caused because of it. And despite institutionalizing loss and damage in the Paris Agreement and the Warsaw International Mechanism, nothing much has been done. So it is often considered as a politics of words, and developed countries have resisted the inclusion of words like responsibility, liability, and compensation in any official negotiations, so that they don't have to pay up for their historical responsibility of emitting more. So the following study acknowledges the lack of global action and attempts at establishing a preliminary understanding of loss and damage on a state level in India, because when it comes to developing countries or even developed countries, research on loss and damage and climate change is extremely limited, except Bangladesh, which has been treated as a very important point of study in this study also. So loss and damage. So loss basically refers to the negative consequences for which no repair or restoration is conceivable. And damage, on the other hand, refers to the negative consequences that can be repaired or restored. So also there is an absence of any official definition of loss and damage due to climate change. And it has been highly political and a contentious issue in climate change negotiations, because people do not want to. Hello? Okay.
You can continue.
Okay. Because developed countries do not want to accept that the extreme events that are being caused are because of climate change. So there is a certain history of loss and damage too, which I would skip. So what are the impacts of extreme events and disasters? So basically, there are natural changes in the physical environment, there are ecological changes, and a lot of socioeconomic changes that happens to human and social assets and situations. And these cover both economic and non-economic losses, like that can be quantified in monetary terms, like loss of infra, or non-economic losses like loss of health or nutrition because of a certain extreme event. So loss and damage has been coming in the forefront because of the developments that have happened in the attribution studies, which is basically the science of attribution, which has evolved so that we can now categorize that this is the amount of extreme event that can be categorized because of the increase in emissions or because of climate change, and this is because of what has been caused because of natural variations. So, and it is highly politicized because it can be used as a way of climate litigation to ensure climate justice, and developing countries can hold the developed countries accountable for their existing emissions. So my problem formulation basically consists of how loss and damage is a very unexplored territory as a subject matter, and advancement in attribution sciences establishes a sound scientific base to study loss and damage, and prevalence of vulnerability hotspots in the global south, lack of international compensation or support mechanisms, and something as very critical for developing countries like India, who suffer immense economic loss and damages because of extreme events every year. So the method that I've used is like a mixed method research approach, which uses both quantitative and qualitative research, where a statistical analysis of a 60-year data set for loss and damage of Assam due to floods has been done, given the current scenario that had erupted in Assam like a few months back because of torrential rains and flooding. And a qualitative research has been done through a way of descriptive assessment of Assam's state action plan on climate change and the measures it has to mitigate flood impact. So this is the state map of Assam and the 17 worst flood affected districts in Assam. And we have done a sectoral impact study of loss and damage across agriculture, housing, and public utilities. And we have also tried to identify what could be the reasons, which have been discussed much in detail in the paper, but not in the presentation. So as we see the trend analysis of the past 60 years, it is very clear that the economic loss and damage to crops, or like in agriculture, have increased immensely, and increasing trend, which peaks after 2015, which is an indication of how the situation is worsening. And agriculture is extremely crucial for Assam as it is still an agrarian economy with like 86% of its rural population depending on it. And also agriculture contributing about 25% to the state GDP. So this increasing trend was attributed to after in-depth research through increased cultivated area that has happened and the higher frequency intensity of floods that has been seen post 2000s. There is increased exposure as the population per square kilometer has increased and increased vulnerability as Assam continues to be one of the poorest states in India with almost 31% of the population below poverty line. Here also we see the trend of damage, loss and damage to houses being extremely lopsided towards increasing after 2000. And the reasons identified were quite similar to what identified earlier. And the similar trend is seen when it comes to public utilities. And the total loss and damage also peaks post 2015. So basically, our observations were that all sectors exhibited a clear increasing trend in the analysis, and all three sectors experienced a sharp increase after 2015, with the highest levels also reported between 2015 and 20. And a decadal analysis was also done in which 2011 to 20 decade was the one in which it was culminating in a peak. So further to understand, like because of the loss and damage that Assam is suffering, does it have enough institutional mechanisms that can support or help in building resilience against these things? So the analysis of institutional mechanisms to avert, minimize, address loss and damage in India was done. So loss and damage is not explicitly mentioned anywhere in the public policy of India currently, but I tried to understand if there was certain provisions that were made towards it. So for the same, we identified the State Action Plan on Climate Change, which is a climate change specific specialized plan for each state. And then I did an analysis in which I saw that Assam as a state, like there are certain things that needs to be fulfilled, but it fell short on most of these factors. For example, vulnerability assessment. So it did not have a proper physical vulnerability assessment, and the anticipated economic vulnerability that was going to come in the future was also something that was borrowed from other countries and was not done as like a primary study by the state. The targets and goals were not present in the area of loss and damage because again, it is a relatively uncharted territory. And institutional systems for decision making in case of loss and damage were absent. The proactive actions that were measured in terms of reducing the impact of extreme events were just measured, and no on ground projects had been conducted. And similar was in the case of governance structure. So an analysis of the approaches to address loss and damage was also considered by looking at its detailed plans of disaster management and its disaster management authority and its functions. And what emerged was that the structural risk reduction measures, which are basically infrastructure that you build to avoid a risk of extreme event, had an overabundance of emphasis on techno-engineering approaches for flood control, like dams and other infrastructure, which can be often counterintuitive if not planned properly, which should, and again, these should be viewed with a political and ecological perspective, because just going with the techno engineering approach doesn't always yield the best results, as we can see in case of the increasing loss and damage in the past 60 years. Then the current non-structural risk reduction measures also appear insufficient to address the severity of the problem, because apart from a flood warning control system, there were none of these non-structural risk reduction measures that aim at awareness or creating personal capacity in dealing with extreme events. Risk retention policies, which are basically post-disaster support that is given to the population in terms of gratuitous relief, was also almost absent and very extremely insufficient. And the same goes for risk transfer measures, which are insurance mechanisms that ensure that post a disaster, people have sufficient funds to rebuild their lives and do not have to indulge in livelihood eroding coping mechanisms. So conclusion for our research was basically that although there has been an abrupt increase in flood losses and damages in Assam, it cannot be completely attributed only to climate change, as we have attributed it to a number of factors as discussed earlier related to vulnerability, exposure, and other reasons. But our results are definitely consistent with previous literature that climate change functions as an exacerbating factor in the frequency and intensity of extreme events such as floods causing increasing losses and damages. An examination of Assam government's flood relief initiatives indicated that they were explicitly promoting techno-engineering approaches and had inadequate risk retention measures and fundamentally lacked any risk transfer mechanisms. And a comprehensive examination of this Assam State Action Plan on Climate Change also found the absence of any policy, legislative, or institutional mechanisms, frameworks. However, they did have several proactive flood prevention strategies, which could help in decreasing loss and damage, but they did not have a timeline or any funding sources. So they were just mentioned as plans. So the State Action Plan on Climate Change also does not address any of the non-economic losses that I had discussed, which can be very important for a community that is recovering after an extreme event. So going forward, despite the lack of formal direction, it is vital that science-based aims and contributions related to loss and damage be incorporated in our revised future plans, given its increasing importance as demonstrated in this study. As we see the increasing loss and damage, the development of a framework, checklist, or a structure for analyzing institutional procedures that deal with loss and damage can be duplicated nationally and internationally, or something that can be worked in the future. That is something related to this research that it can be taken forward. Thank you. I think we're done.
Thank you very much, Ms. Soumya Jain, for this wonderful and detailed presentation. The session is now open for questions.
Soumya?
Yes, sir.
So, what is your classification for these, your suggestive measures? Are they structural or say non-structural measures to minimize the flood loss?
So it's like, so for each of these different three measures that I've discussed, for all of them, I'm suggesting improvements. I'm not saying that we should go for structural or non-structural, but all of them require improvements, because as discussed, like the structural measures also that Assam has taken have resulted into a lot of problems, because they have straight out like gone building lots of embankments, which can also serve as a problem, as there are lots of embankment failures depending on the construction or the quality of construction. Then it also creates problems for fishes and the marine ecosystem there. So I have suggested measures in each of those three measures.
Okay. So, and the second question is, this means what is the major reason behind this Assam's flood?
For Assam floods?
Yeah. Assam's
So it is,
flood, your topic is Assam's
yes,
flood.
yes. So I think it's a combination of a lot of things. I cannot say it's only because of climate change, but Brahmaputra originates from Himalayas. And because of increasing temperatures, the speed of melting glaciers is increasing to a very fast pace, and because of which flooding has become very intense, if not frequent, which can be seen through the scale of disaster that keeps on increasing by the increasing economic loss and damage every year.
Oh. Okay. Yeah, Shubham, others can ask the questions.
Okay. Any questions from participants? Okay, thank you, sir. And thank you, Soumya Jain. So next paper ID is paper ID 38, but paper ID 38 is absent. So we will move on to paper ID 43.
Hello. Hello, I'm Rishikesh, and can you hear me?
Yes, you are audible.
Yeah, thank you. And it's visible also, right? So
Yes.
My paper is on climate risk assessment and adaptation in small and medium enterprises, lessons from Andhra Pradesh. Basically, I work with German International Cooperation, and so we work with JIZ and Integration and other partners on this project, and we thought we come up with a academic paper as well. So basically, we all know that there is a substantial evidence of
Mr.
global
Rishikesh,
temperature.
can you please play your presentation in slideshow mode?
Yeah, it is there in slideshow only. Okay, I think so.
In full screen mode.
Yeah, now it's visible. Now it's visible.
Yeah, now it's visible. Yeah, please continue.
Yeah, okay. So there is we all know that there's a substantial increase in the global temperature, and it has been proven. And we all know that the intensity and frequency of extreme weather events are going to increase. So what is one of the solution is mitigation. That is something what we know. We try to control the carbon dioxide entering into the atmosphere, or increase the source of sink or sink. But another aspect is adaptation, where we try to cope up with the extreme climatic events, or come up with some kind of opportunities that can cope up with future climate events. So climate risk, before that we have to carry out climate risk assessment, and this risk assessment is one of the approach to understanding how vulnerable the sector or the region is. So basically it involves exposure, climate hazards, impact, vulnerability, resilience. So when we come to industrial parks in India, industrial parks are defined as a quality infrastructure facilities in the form of plots, develop or built-in space, and made available for the industrial activity. But there are many definitions: industrial parks, industrial estate areas, development authorities, and we also have theme parks like biotech park, leather parks, processing zones, special economic zones, free trade zones. And in the recent last 2 decades, the national investment and manufacturing industries, growth centers, PCPIR, and now the big industrial corridors are coming up. So all these are economic activities. These regions are very susceptible to extreme weather climate. So the present project or present study aims to examine the climate risk assessment of MSMEs in Visakhapatnam city in Andhra Pradesh in southeastern coast. And we try to understand the qualitative analysis from direct and indirect impact of extreme climatic events on industries through in-depth interviews. So Visakhapatnam, as you all know, that it's in the southeast of India, southeast coast of India, and it's one of the 3rd largest city in the coastal eastern coast. And a new industrial corridor is coming up that's called ECEC, that's Eastern Corridor, and where VCIC is Visakhapatnam Chennai Industrial Corridor is coming up, where many industries are going to come up in the future, many sectors, many industries, and overall MSME forms almost 99% of the overall industry. So this region is prone to cyclone, heat wave, heavy winds, and heavy rainfall. So some of the experience from 2014 cyclonic event, how the industrial areas are being destroyed, and how you all can imagine how impact it would be. So we have come up with a overall climate risk assessment, where climatic hazard and exposure and vulnerability will be assessed, sensitivity and adaptive capacity have been assessed. And then when we enter into within the industry, we have seen ownership aspects, size of the industry sector, geographical location, because the climatic impacts are regional or local level also. Local because of topographic conditions. Then we also assess the physical conditions of the industry, within the industry, and external infrastructure that is leading to industry, like road, electricity, water, etc. Then processes, the core processing zones and non-core areas like warehouses or office spaces and etc. Then supply chain also we have tried to understand the upstream side from the of the industry, at the industry when from the raw material to the industry, and from industry to the finished goods. Then we also address the employees and communities during the event and aftermath of the event. Generally, aftermath is because in tropical countries we are mostly prone to waterborne diseases aftermath of the and also these workers work in a very deteriorated working conditions, and absenteeism may also increase. That may also have an impact on the productivity of the industry. Then markets, how markets are behaving, finance, in availability of credit. Most of the MSME sector do not have insurance. Government policy to support such events. There are hardly any policy. They just go for a one-time small payout. And also how adaptation has played an important role in coping up with extreme this event. In addition to that, we also assess what are the barriers and drivers that may cause the adaptation measures for the industries. So we have selected some 7 industries covering tire retreading, wheat processing, metal processing, transformer manufacturing in one of the industrial areas called Gajuaka in Visakhapatnam region. And so with the employment from 10 to 150, this is the MSME sector basically. So we found out that cyclone and storm has a massive impact on the industries. This has an impact on workforce, production, and building and structures. The 2014 cyclone, what they have experienced was the worst in their lifetime. Then they also have a regular or frequent heat wave, which happens in summer. Being a coastal city, that also has a high humidity. So high humidity aggravates the heat condition and impact the productivity of the workers. Then localized flooding is not much, very low, because that industrial park is mostly a flat region. And the water scarcity was also not a major issue there. So we actually assessed the climate risk due to cyclone and heat wave, because these were predominantly dominating in this industrial park and this city as well. So we tried to assess in terms of buildings and logistics process, then employees and communities, government, markets, and finance. So then we come up with a each individual industry adaptation plan, which included cooling of companies. We propose certain measures to cool the interior spaces, building of companies, then simple paints which can be easily painted to reflect more heat. Then certain specific adaptation measure for food industry also we have proposed, and foundry industry, because they have a very specific need to abstain from humidity. They want to go away from humidity, so they want a much drier spaces. So we propose similar adaptation measures. So and we also propose high wind resistant buildings, and also we were able to integrate different adaptation measures from different hazards. So for each industry, we come up with generic measure and specific measure, like anchoring of roof structures. That's something which we propose to all the industries, because most of the industries have lost their shed roofs during the cyclones. Similarly, for the heat and tropical cyclone building, we propose a light colored roofing, highly sun reflective surfaces, then effective anchoring of roof, sturdy shutters, improved nuts and bolts, and it was more a specific industry specific adaptation measures. So adaptation measures, we also looked into the potential for its upscaling, its need overall in terms of win-win or no cost adaptation measures, so that or low cost adaptation measures, because we need to propose measures that even in next 10 years a cyclone does not hit, the investment should not go waste. So we have to take into consideration all those things while we proposing the adaptation measures. And yeah, we also propose certain modification which is on a long-term basis to the existing building, and if they are constructing any new building, to take into consideration the impact of cyclones and heat waves. So again, we come up with a different adaptation measures that should be implemented for these 7 industries in terms of short-term, mid-term, and long-term. That includes like strengthening of roof, improving cross ventilation. This was mainly required for the wheat industry, the food industry. Roof insulation, it was there for all, because the heat wave persists for nearly 2 to 3 months in Visakhapatnam. Insurance was a major thing because most of the industries do not have it. Heat and tropical cyclone resilient planning, dry storage, especially for food and foundry industry. Dehumidification, this was mainly for, I think, for foundry industry, because the sand absorbs the, they use sand, fresh sand for molding. So, but sand absorbs the heat, so they keep on heating to keep the sand dry. They keep it warm, so a lot of energy is consumed. And renewable energy and rainwater harvesting. So basically, climate change adaptation is very site specific and industry specific. It needs to be done at an industry level. In addition to that, there must be a guideline actually to come up with, like what we have in earthquake-prone zones. We should also come up with cyclone-prone zones. Although we have some wind level, thing, but yeah. So climate risk assessment should be a part of government's initiative policy, and also all industries should carry out. But yeah, nowadays big industries are coming up with TCFD and other certification where climate risk is definitely taken into consideration. But yeah, MSME has a long way to go. Thank you. I think. Yeah, thank you.
Thank you very much, Mr. Rishikesh, for this wonderful presentation. The session is now open for question and answers.
Did you consider the multi-hazards in your study? And simultaneously,
both. Both tropical cyclone and heat.
Tropical
heat
cyclone
wave.
and
heat wave. So the effect of tropical cyclone will also have a heavy rainfall and wind. So that's a secondary impact.
Can you did you understand my question? Means multi-hazards means at the same time 2 types of hazards are there in the, say, earthquake plus.
So when the tropical cyclone hits, so tropical cyclone hits, there is a heavy wind and heavy rainfall.
Okay.
So that has been considered. Yes.
Means the flood and high wind at the same time. Yeah. Okay.
Yeah, rainfall can cause flood or may not cause flood, but yeah, both all 3 has been considered.
Okay. The others make an ask.
Any other questions from participants? Okay. Thank you, Mr. Rishikesh, and thank you, Dr. Kedar Sharma, sir. We will now move to our next presentation, that is paper ID 46.
Shubham, how many presentations are more?
Sir, this one is last.
46 now?
Yeah, this one is last presentation.
Okay.
Paper ID 46, you may now share your screen.
Sir, just I'm sharing my screen.
Okay.
Sir, is it visible? Hello.
No, it is not visible yet.
Just wait.
Yeah, now it is visible.
Am I audible, sir? Is this screen visible?
Yes, you are audible. Your screen is visible.
Thank
You
very
can
much,
switch
sir.
on to slideshow mode, full screen.
It is on the slideshow mode, sir. Full screen. Presently, it is on slideshow mode, sir.
It is not visible in full screen.
Just
Greening the Indian Defense Forces. Conceptual
is it
framework for
on your
sustainable
screen now, sir?
carbon.
No, still not.
Sir, because
Okay, you can start your presentation.
You share your complete screen.
I just try, sir. I'm sharing my complete screen.
Just stop sharing and share again, then it will work.
Right. So give me a second, sir. Is it okay now, sir?
Yeah, now it is fine.
Right. Thank you very much, sir. My paper ID is 46, and my name is Chetan Devat. I am research scholar from the Victoria Veer Mata Jizabai Technical Institute in Mumbai. The title of paper is Greening the Indian Defence Forces: Conceptual Frameworks Towards the Accelerating Carbon Neutrality in India. This is more of a very initial stage of conceptual framework. Some of the countries, developed countries, which are more sensitive towards the environment-related issues, have been practicing this. And with the time, we also need to start thinking and perhaps to some extent start practicing the green defense framework. Hello.
Yes, you can continue. You are audible.
Yes, sir. The slide is it got hang, sir. It is not moving to the. It is not going to the next slide. Yes. Okay. So I intend to cover the presentation in these parts, 7 parts. Briefly, I will talk about before I start the introduction, basically some terms of references. Since it's a defense-related subject, only the information with respect to environment is being discussed. No sensitive topic is being touched upon this. Only the information which is available in the public domain is considered for this presentation, or anywhere in the paper linked with this topic. The introduction, in short: Indian Defence Forces, they have a very impeccable record of meeting their targets, whether it's operational target, non-operational target, or anywhere. The Indian citizens rely very heavily on the Indian Defence Forces and carry immense respect for them. The climate change is a threat multiplier. Definitely, India is one of the most vulnerable countries with the long sea coast and the ecologically fragile areas. With time, in addition to the enemy-related issues and the difficult terrain-related issues, the uncertainties of climate change also needs to be taken into consideration by Ministry of Defence. Third is the increased role of defence forces everywhere, whether it's a flash flood, cyclones, heat waves, landslides, as recent flash floods in the Bangalore, everywhere and almost anywhere, army, Navy, Air Force, they are first immediately called upon service to as an aid to the civil authorities. Fourth is the defense forces. Of course, this is the opportunity for the Ministry of Defense to project image also as a climate warrior and planet protector, and not just the protected polluter, as many environmentalists, particularly in European countries, say. Taking the initiative would also act as an example for our neighboring countries that we need to be sensitive towards the environment issues as also. Literature review: in addition to various engineering related literature, here I have primarily focused on some of the literature which is primarily from the various annual reports of Ministry of Defense of India, United Kingdom, NATO related documents, IPCC report and International Military Council on Climate Change Security reports. The problem formulation in short, it could be to recommend initiatives which can be implemented by Ministry of Defense of Government of India, which are sustainable and they are at par with few developed countries. And of course, we'll have some will display some concern towards addressing the environment and environmental issues as well. The climate change does not spare anyone. The effects of that are almost visible everywhere. The rising sea level, number of the cyclones, intensity is going to increase repeatedly. Just 2 months before, this was from the cyclone Taukte, which hit the western coast of India. The damage only to the naval infrastructure was close to 3,000 crore. On the entire infrastructure, somewhere it was 15,000 crore. Couple of years before, the similar cyclone Hudhud, which had a severe impact on the eastern coast, eastern coast of India, where again the damage was close to 2,000 crore to the naval infrastructure related things. It is not only the Navy, the Army, which remains deployed in the north and northeast of the country in a very ecologically fragile state. They also face a burn of the climate change related issues. This is just recently, just 2 months before, in July, there was a landslide and 42 people died in that. Out of 42, 30 were the serving soldiers of the army. This is one of the answer in the parliament. In 3 years, between 14 to 16, 58 soldiers, serving soldiers, in some or the other natural calamity related issues have lost their life. The world is basically going through the transition phase. Here we can see all the transition phase is guided by the World Bank, and in case of India, it's by RBI. They are monitoring and they are pushing everything towards the sustainable development. So when the world is going through the transition, subsequently, or now, we need to also start thinking and implementing some issues with respect to defense, which will not be only defense, but a green defense, which is more friendly, which has some friendly environmental policies. To see this, we'll just I will briefly mention about the journey of India. Basically, India has a very strong aspirational journey to emerge as a climate power. Since 2018, the time we have adopted the National Action Plan on Climate Change, which had 8 missions. 3 of them were of the mitigation nature and 5 were of the adaptation nature. Subsequently, these were of the initially generic nature. So we focused on the NDCs in 2015, nationally determined contribution. We started quantifying our targets. So that here the emission intensity of GDP was decided to be reduced by close to 35%. Further moving step ahead in COP26 in Glasgow concluded this year, we quantified the targets and have a very ambitious targets. We also gave our desire to become to achieve the path of net zero emission by 2070. We are specifying that we need to reach 500 gigawatt of non-fossil energy capacity by 2030. So when the country is moving with so much of ambition to emerge itself or prove itself as the leader of the emerging leader of developing and the poor countries, where India takes the lead of the agendas, climate-related agendas on the international forum. It's been leading, particularly with respect to climate negotiation, climate fund, climate justice. So when the country is doing that, a bigger organization like Ministry of Defense can also contribute in a significant manner. That's what we intend to explore in this paper. So what is the present situation? Of course, the present situation, there has been a very positive contribution from the Army. This is available in the website on the Ministry of Defense. In the Army website. It talks about the cell, which is functional environment ecological cells. Couple of the initiatives have also been mentioned, which as an organization, it has been taking from time to time. What is the main thing lacking is the quantification, which is the engineering aspect. But every action is leading to what amount of every action would lead to what amount of reduction CO2 equivalent. That part has not been mentioned anywhere. This is again available in the public domain, one of the important documents, Joint Doctrine of the Indian Armed Forces, which was adopted in 2014. The joint doctrine of the many of the developed countries, they talk very extensively about environment related issues. Here in this document, which is close 93 which is of 93 pages, the climate change word has just come once, and it is called as a non-traditional security threat in the changing security scenarios. We see the second important document, which is there in the public domain, Annual Ministry of Defense Annual Report 2018-19. This is the latest available on the internet. So even this document, the climate change word has just come once. We can see that too as one of the affiliated institute IDSA. Second, if we look for the other important words, particularly with respect to environment, that is carbon emission, sustainable, it has not been figured it has figured hardly at hardly any place, particularly with respect to environment issues. So we see the emission word has come just once in the document of 280 pages. This is again not, this word is, in this case, it is not with reference to the environment issues. The sustainable word was mentioned at just one place at page number 122. Now this has been with respect to Ministry of Defense of India. We can take some positive lessons from some of the countries. This I have referred to the two Ministry of Defense reports of United Kingdom, 2019-20 report and 2020-21 report. So this is a report is again almost of 250 pages, something close to what our report. And in this report, the 14 pages have been dedicated for the environment related issues, and in what manner as an organization, Ministry of Defense is contributing towards meeting the environment goals, and how it is contributing in their country's environmental targets. So this is the front page of the MOD report, which talks about the content and performance. I'm taking your attention to the strategic objective 4. Here they are talking about transform the way we do the business. The strategic objectives are in the MOD reports are the main things, are the important targets which are desired to be met in a time-bound manner. The second is about, it talks about Annex D and Annex E, where it is talking about energy and carbon emission data, water and waste data. So let's see what in the strategic objective 4, what they mean, how it is linked with the environment goals. So this is the strategic objective 4. It talks about the last point, reduce greenhouse gas emission from state and business travel by 45%. That is which this basically reflects the concern towards reducing the GHG emissions as an organization. And this is being done without touching any sensitive issue or any security or operational related issue. It is primarily state energy and business travel. So with respect to baseline of 2009, they are talking about reducing the emissions by 45%. The entire 14 pages, as I mentioned in the annual MOD report, it talks about various environment issues under these head mentioned. Under paragraphs or sub-paragraphs. One is the sustainable MOD, sustainable development goals, greening government commitments, sustainability, state energy, business travel, and so on. All these, the interesting part about all these paragraphs or the sub-paragraph is everywhere the quantum has been defined. Every step has led to what? Every step has led to reduction by what percent is clearly brought out. They have also acknowledged at places that the progress has been slow, but the progress has been displayed, and that is a very positive step because it is not the organization, it is the organization and the entire family members and moral attitude towards these concerns are reflected in the report. Finally, the report links all the actions taken by them to the United Nations Sustainable Development Goals. Here it is showing the transform the way we do business. All the climate-related issues. The second category is protect our people. Third is project our global influence. Fourth is promote our prosperity. So these are the Sustainable Development Goals linked with the actions taken by the Ministry of Defense of the United Kingdom. So looking at the plus, there is also North Atlantic Treaty Organization, which is military alliance of 31 countries. They have also adopted Green Defense Framework in 2014. This part of, since the time is short, so I will not be touching upon these topics. So in short, how we can summarize when the other countries are doing so much, what we need to do. This is how the topic can be summarized. We need to have a doctrine, perhaps the green doctrine, and a vision, 5 years or 10 years plan, in what phases, what can be implemented, and everything would lead to what amount of will lead to what amount of emission reductions. Secondly, a framework for the adaptation mitigation. This framework could be under the various head. It can include renewables, transport, estate emission, paper reduction, even the best practices. All of these can be quantified with respect to emissions, and as per the sensitivity, they can be disclosed in the public domain. This is how I finally conclude that disclosure would be as per the discretion of the Ministry of Defense. However, overall, as an organization, it is time to show to the world that as an organization we have a concern towards the NDCs, and we strongly believe in supporting the country's environmental targets. This finally can be, in case of India, similarly NDCs and the MOD and the Sustainable Development Goals can be linked. These are the references I have gone through for preparing the research paper. That's all from my side. Hello.
Mr. Chetan, for the detailed and wonderful presentation. The session is now open for questions.
Yeah, Chetan?
Sir.
Did you able to get some data for Indian Army, or say means our armed forces?
Sir, in the present, yes, sir. What data as such, whatever is available in the public domain, I have referred to only that data.
Okay, public domain data, right?
Yes, so it is only specific, very specifically public domain data. That's how I slid in the first slide itself, that referring to the only public data which is in the public domain.
Okay. Okay, so others may can ask.
Any questions from participants? Okay, so with this, we concluded this session on recent developments in energy conservation and sustainability. I would like to invite Dr. Kedar Sharma sir for his concluding remarks.
Yeah, the nice presentation, and then they means in future what we can do for sustainability, even in the for the some new energy sources like the hydrogen, and the initiatives which can be minimize our energy requirement, particularly as in the last presentation as in the armed forces. So other presentation which is also means the related to the flood assessment in the Assam, and the two more presentation, one is the sustainability and etc. So all these presentation are very good, and I means the thanks all the participants for presenting their work. Thank you.
Thank you so much, sir, for your comments and suggestions. I hope your comments, your constructive remarks will help the participants to improve their research work. I thank Dr. Kedar Sharma sir and all the participants for attending this technical session. Thank you very much.
Yeah.
Thank you, sir.
Goodbye.
Thank you.
Thank you,
Thank
sir.
you. Thank you.